So welcome to day two, the tutorial day. The first tutorial is going to be a tutorial by me on advanced project building. So that's how can we use some of the advanced features that the Zooniverse platform provides, and in particular the ones that aren't really that accessible through the project builder. So the code that you can see here is available from the GitHub repository, which is of course here. To the advanced project building folder in the GitHub repository, and then into the notebooks folder there. You can see this IPython notebook called advanced project building, and that's what I'm going to be working through hopefully over the next hour or so. I guess all the usual caveats apply, which is that actually this is the first time that I've worked through this in anger with a live audience, and I have tested it, but this is a live demo, so that almost guarantees that there might be some issues. So please bear with me if that happens. And we'll be doing it in reference to the little demonstration project that we set up yesterday. Okay, so first of all, this is all code in Python, but it is going to rely on some packages, and hate me if you like, but I'm a big fan of a package called pandas. So if you don't normally use pandas, then you may need to install it. If you do need to install it, that can be done with pip using this command here. You would uncomment this cell, and obviously this exclamation mark is just part of the Jupyter interface to run a shell command from within a Jupyter notebook. All of the rest of these packages are standard packages, and one of the non-standard package that I'm going to use for this demonstration is the Panoptes client package, which was, in fact, to give him his credit, he's on the call, was written by Adam McMaster, who is now at the Open University. It's an excellent package. It lets you interact with this system called Panoptes, which is actually, it's the name for the back end of Zooniverse. It's the computational infrastructure that does all of the magical Zooniverse stuff. And the Panoptes client lets us do things like log into Zooniverse, create new subject sets, create new projects if we wanted to, and create new subjects and modify aspects of our project that we've already created. Okay, I'm going to get out. The first thing I want to do is just define a variable for the directory where our data are kept. So if I just very briefly open here, I'm running a notebook in the notebooks directory from that advanced project building folder in the GitHub repository. Our data are stored in the adjacent data folder here, so we can see we have some data here that we're going to use for this tutorial. And so what I need to do is just set this up, a Unix-like system. So I need to specify that this directory is one directory up and data, and that's it. If you're running on a different system, or for some reason you've moved this within your file system, then you're going to have to set that to a different path. But hopefully, if you're just running from within a GitHub repository that you've cloned, you can do something very similar to this and it will work. Okay, so let me actually just start running some of these cells. Just import the modules and packages that I need. Define that. I don't need to install these. If I did need to install these, I would change that cell from raw into code and then run it, and it would install both of those packages if I needed to. In fact, to be honest, I would have had to install pandas before running this, or it wouldn't have succeeded. Okay, so I'm just going to change that back to raw now because I don't need that. The next thing I need to do is import various classes from the Panoptes client package. So I'm going to import this Panoptes class, and that's kind of a general umbrella class. It's a bit like, I guess it's a bit like clicking on the project builder. So this lets me do things like log in and communicate with Zooniverse generically. I'm going to import a class that represents subject sets. I'm going to import another class that represents individual subjects that live within those subject sets. And then finally, one more class that represents projects. Okay, so let me do that. Excellent, we're all going so well. So now what I need to do is I need to pretend that I've arrived at www.zooniverse.org, but I'm not logged in. So I need to log in. I can then modify my project and work with my project. So this cell, this is just standard Python type stuff. This has got nothing to do with Zooniverse. All I'm going to do is enter my username and then enter my password in a way that you can't see it. So if you're a hacker, you now know what my username is, but you will not know what my password is. You will know how many characters it has. Okay, now that I've got those two data, I can actually connect to Panoptes using this method, Panoptes connect, and it just takes two arguments, username and password. Later on, I'll talk about an alternative where you won't need to enter these credentials over and over again, but it is a little bit more advanced. So let's click on that. And now we're logged in. Okay, so the next thing to do, again, we wouldn't necessarily have to do this. We could just keep entering this number over and over again. But I'm going to keep a reference to what my project ID is. So let's just remind ourselves where we left our project before. We left our project with some of the various fields and stuff filled in. And we defined some workflows, and we created one subject set. Okay, but the project ID, which is the number that I need, is this number up here. So it's 14077. If you went to the trouble of building your own version of this project, your project ID will be different, and you'll need to enter a different project ID here. So let me do that now, 14077. And then what we can do is we can use this method here, which is find on the project class, and we pass it our project ID, and it will basically go away and create a representation in Python of our project. Okay, so let me do that. Seems to have worked, and let's check we got the right project. So what we can do is we can display various attributes of our project that we've just located. So we can display its name, the description, the introduction, how many subjects that project has, and how many classifications have been done. Okay, so let me just run that. And we can see that thankfully we found the right project because the name is Super Wasp Lite. And if you remember from yesterday, these are indeed the details that we entered for the description and the introduction. We have some subjects, but we haven't made any classifications yet. Okay, so now what I want to show you how to do, and let me just do this with reference to the project builder again. If I click on new subject set here, you remember from yesterday that we see this recommendation that if we want to upload large subject sets, we don't do it through this interface. We don't want to drag 500 files into this box and wait for them to upload through the interface. It's much better to try and do it in one of two ways. One is using a command line interface. So that's if you're familiar with Linux or Unix terminals, you can do something on the command line and upload lots of files. Or you can do it the way that we're about to do it now, which is to use the Panoptes client package for Python. Okay, so that's what we're going to do. We're not actually going to upload a lot of files because, again, my internet connection isn't really fast, and that's the bottleneck, but we're going to show you how you could do it. Okay, so the first thing that we need to do, we're still logged in, we need to create a new subject set. And I'll tell you what I'm going to do. I'm just going to hide that so you can see more of the screen. So to create a new subject set, that's really easy. We just call, this is, if you're familiar with Python, we call a constructor of the subject set class. And then once we've created it, we need to give it a name. So we're going to call this one Python demo set. If you remember, the one we created in the project builder was just called demo set. Okay, so I'm going to run that cell. Okay, and that worked fine. And now what we can do is we can go and check that this has, actually, we can't check that yet. The next thing we need to do is we need to link this subject set that we've created with our project. So we need to say that this subject set belongs to our project. We already found our project up here. Okay, so we have a reference to that project. And so what we can say is we can use what's called the links attribute of our subject set and the project attribute of those links, and set that to be equal to the reference to our project up above. Now, I'm using a lot of Python jargon here, so if you're really not following, please just unmute and say, Hugh, I'm not following, and I'll explain it hopefully in a bit more detail. Okay, so now that we've done that, we can save our subject set. At the moment, our subject set only lives on our local computer's memory. The Panoptes system doesn't know about it at all. In order to tell Panoptes about it and basically send a message over the and say create our subject set in the Zooniverse infrastructure, we need to run this save method here. So let me do that. Hopefully it will work. And it will send us back a response. And I suppose what I should do is just check what that response is. And yep, so we get a response back that isn't an error. It's telling us that it's created a subject set, and you don't need to understand what all of this stuff is, but at least it's telling you that it's worked. Let's check a better way that it's worked by going back to our project builder. Let's just click off here and come back to subject sets. And what you can see is that here's the untitled one that I just created by mistake, but here's the Python demo set that we've just created from Python. So it did work. Okay. So hopefully that's fairly straightforward. So that's the subject set. Just to show you, at the moment, it is completely empty. There's nothing in it. So we need to add some subjects to our subject set. How are we going to go about doing that? So I've written some text here that you can come back and review if you want to. But basically, it's quite similar. Creating a new subject in Python is quite similar to the way we created a subject set. Okay, so what we're going to do is we're going to create several objects which are instances of this subject class, and we do that using code that looks just like this. So we're going to make a new subject, and it's equal to an instance of the subject class. Okay, then we need to do a very similar thing. We need to say that our subject belongs to our project. Okay, then so that's really similar to what we did up here. Okay, then obviously our subject has some images associated with it, or some media associated with it potentially. Okay, and to tell our subject what those images are, we use a method which is called add location. Okay, so we have our subject that we've created, we've associated it with a project, and now we need to add some media to it. And so we use add location, and you can pass in one or more media types. Okay, there are more advanced ways to use this function, but I'm not going to go into them in this tutorial. Come along tomorrow and we can discuss them in a lot of detail. Okay, then what we can do, if you remember when we were uploading through the project builder, we made what's called a manifest file. And the first column in that manifest file was the image path, the image name. And then there were other columns in that file, and those columns became metadata. So the question is, how do we create metadata within the Python interface? And to do that, what we need to do is set this attribute on our subject, which is just intuitively enough called metadata. And what we do is we set that to an object which is of a type of Python dictionary, or a dict. And this is just how you specify a literal dict in Python. If you're not familiar with Python, this might look like jargon or magic. There's not a tremendous amount I can do about that. But the important thing to bear in mind is that a dictionary is basically, it's a dictionary type object. So it has elements in it, and those elements consist of a key, which is in this case a string that says number of images, and that's going to become the name of our metadata, and a value on the other side of the colon, and that value is going to become the value of our metadata. So if I run these two lines, what I'm doing is I'm saying this subject has a metadatum called number of images, and the value of that metadatum is 2. And it kind of makes sense because our subject does indeed have 2 images, but it doesn't have to make sense. It can be complete gobbledygook if you want. It's just not particularly sensible. And then once we've set that attribute of our subject, then again, we need to save it. And when you run save, that's actually going to get these media from your local machine and upload them. So it takes a little bit longer than saving our subject set, because it's uploading potentially large images. Then finally, once we've saved our subject, we can add the subject to the subject set. Okay, and when we add the subject to the subject set, That's basically associating it with the subject set. But remember the thing that I said yesterday, which is that a single subject can be associated with many subject sets, which is why you do this as the last stage. So I could add this to many subject sets. Right, so having gone through all of that introduction, let's actually have our first opportunity to break my code. So in our data directory, which is I've set to be data, we have a couple of files. One is called demo set 0 to 10. That actually just contains a CSV file at the moment, which we'll see later. But the one that we're going to use that actually contains our data is this one, and it contains some JPEG images and some manifest information in case you wanted to upload it through the project builder. But hopefully we won't need to do that. So let me just hide that away again. And so what this command is doing is it's finding all the JPEGs in that directory. And so if I run that and then print out the files that we found, we can see that yes, we found those files, which is good news. So we have our media, and we're going to try and create some subjects from those media. Okay, so the first thing I'm going to do, I'm actually going to create all of the subjects in a row. Okay, so I'm going to create all of my subjects first within this loop by looping over the image files that we found. And then once I've done that, I'm going to add them all in one go to my subject set. So the argument to this add to the subject set, it doesn't have to be a single subject, it can be a list of subjects as well. So that's what I'm doing here. I'm creating for every image in my list of files, I'm creating a new subject. I'm linking it with my project. I'm adding a single location in this case, which is one of these file paths. Then I'm setting some metadata. So I'm going to set the origin to be Python demo so that we can identify those images that we uploaded from our Python demo. I'm going to set image to be the file name of the image, and that's really just to make it conform with what we did yesterday, because if you look at the metadata of the images we uploaded yesterday, they have a metadatum called image. And then I'm also going to upload what's called a hidden metadatum. Why is it hidden? It's because volunteers don't get to see it in any context. How do I enforce the fact that it's hidden? I just prepend the metadata name with a, well, Americans would call it a pound sign. I would call it a hashtag or something like that. And then I'm going to give this actually the full path here. You can have as many hidden metadata on a subject as you want. I think within reason. If you tried to upload terabytes of metadata, it probably wouldn't be very sensible. And it can be really useful for doing your analysis when you get your classifications back, because you will be able to associate it with subjects and you'll be able to get those subject metadata if you haven't kept them locally for whatever reason. It can also be useful because some hidden metadata are used by the training and feedback system, and I'll talk about that a little bit later. So once I've defined this metadata, again, so key value, key value, key value, this is just how we define a dict in Python. I save my subject, and then I'm going to add that subject, not to a subject set, but just to this list for the moment, this list that I've created up here. Okay, so bearing in mind that while this is running, it's calling save, it's going to be uploading, I think, 10 files, so it'll take a little bit of time to run this cell. Okay, so let me just run that. And so let me think. While that's running, I can just, in case you weren't here yesterday, why don't we have a look at our subject sets again? And if I just remind you what I'm talking about when I'm talking about metadata, this works now. Metadata, you could see this in the classifier if you wanted to, but you can also see it here. You find it by clicking on this little eye. So the ones that we uploaded yesterday, as I said, they have this image metadatum, which is just the image, and these ones have WASP ID. The ones that we've uploaded from our Python demo, they won't have this WASP ID. They'll have a hidden one called local image ID or something like that, and another one called origin, which will say Python demo. Okay, so let's close that down and go back and see where we are. Still running, takes a little while. Once we've done that, we'll be able to add those subjects to our subject set that we've already created. Okay, so let me just, I've got lots of things running at the same time. I'm going to be faithful and assume that that's running, and we'll move on to the next section because time is ticking on. So the next section is about how we can try and improve the volunteer experience, and the way we're going to do that is actually by updating metadata on existing subjects. Okay, so what we would like to do in this case is so our volunteers, they're doing lots of great work for us, and we know that they kind of like to read around the subject, if you like. So they like to go away and find out new things about the subjects that they're classifying. And in this particular project, SuperWasp Variable Stars, there are other surveys that do similar things. They've gone away and they've looked and created light curves. So basically they've taken measurements on a regular basis of the brightness of these stars, and they've classified them themselves. So there are several of the catalogues that do that. And what we'd like to do is give the volunteers access to those catalogues so they can go away and look at data that aren't from SuperWasp, but are in fact from different surveys. Okay, so the way we're going to do that is by adding a special type of metadata that you don't see in the classifier. So you don't see it when you're classifying, and the reason that we want it to be that way is we don't want these results from other surveys to bias our volunteers' opinions. However, they will be visible if the volunteer wants to comment on that subject in the talk interface. Okay, and the way that you do that is very similar to the way that we specified a hidden metadatum here. So instead of putting a hashtag, what you do is you prepend the name with a exclamation mark character like this. And that will introduce this special behavior where it's not visible in the classifier, but it is visible in talk. If you put the hashtag, it's not visible at any time. You won't see it in the classifier or in talk. So what I can see is that this cell is now finished. So we've uploaded all of our subjects, and now we can run this cell, which should add all of those subjects to our subject set. That ran fairly quickly. And then hopefully if I come back here, just click on that, click on our Python demo set, it tells us, yes, we've uploaded our subjects. Hopefully we'll be able to take a look at one. There it is. And if we look at the metadata, we can see that we have our image and we have our origin, but we don't have, first of all, we can't see the hidden metadatum that we uploaded. We don't have that WASP ID because this isn't from the same upload batch. Okay, so I've proved that my code hasn't yet broken, which is great. All right, so fortunately, we don't have to go away in this demonstration and find all of the information about the other catalogues, because Adam McMaster, again, has gone away and done all of that work for us. And so what we have is a set of links. In fact, maybe I can show you those data. Data here and here. So we have for each subject, each potential subject, there's a big old list here. We have a set of links, and each of these links goes to the appropriate page of the corresponding survey's website for a subject that matches the celestial coordinates of the SuperWasp subject. If there's a SuperWasp subject that doesn't have any matches, then we just see no match. Okay. Right. So what we're going to do, we're going to load this file using pandas into our notebook here. And the nice thing about pandas is it lets us look at it so that we can verify that we have indeed loaded it in. And so what I have here now is a table that's indexed by this number down the side, and then has all of these links available. So we can use these links. We can go through our subjects that we've uploaded, and we can say, okay, our subject was, and this number happens to be the name of the file with .jpeg removed, and we can say, okay, we have that subject name. Can we find some extra information so that we can create new metadata for that subject and upload it? All right. So what we're going to do is I'm going to demonstrate now a way that we can from Python, find all of the subjects that are associated with our subject set. And the way that I'm going to do that is, first of all, find all of the subjects that are associated with our project. And the way that I'm going to do that is find all of the subject sets that are associated with our project, and then find all of the subjects that are within those. Okay, so the first bit is to find all of the subject sets that are associated with our project. And we do that using, again, this links attribute of project, and then links has its own attribute called subject sets. Okay, and then once I've done that, I have the subject sets, I'm just going to print out the names of them. So we should find that there are 3, hopefully. Let's do that. Yep, we have our demos subject set because I couldn't type. We have the Python demo set, and we have that untitled one that I created by mistake. So now that we have those subject sets, we're going to loop over all the subjects within the subject set. So the subject set class has its own attribute called subjects. Okay, so we don't have to use links this time. We're just going to get this subjects attribute, and that you can iterate over that. And so as we iterate over that, we're going to get the information for each of the subjects in a subject set, and then we can check whether that subject is covered by this list. And if it is, we can create some new metadata for that subject, update the subject's metadata, and then resave the subject up to Panoptes. Okay, so that's what I'm doing here. I have my subject set, so I'm looping over my subject sets, and I'm looping over the subjects in each subject set. Okay, so that's what's happening here. I'm going to extract the image ID. Okay, now the image ID, if you remember, let me just come back here again really quickly. I'm going to get that from the metadata. So that's here, and now you realize why I've had this image metadata. It's because I'm going to extract this metadata, take this value, chop off the 4 characters at the end, and convert it into an integer. Okay, and that's going to let me look up in that table to see if I have any links available. So that's what's happening here. So that's what this line does. It's taking the metadata, extracting the image item, chopping off the last 4 characters, and converting it into an integer. Okay, so that's what's happening there. Then this is very compressed Python. I should have done this longhand to make it clearer what's happening. What I'm doing is I'm basically looping through the extra subject info here, where I have a match for my image ID, which is this one. I'm looping through each of the columns, 1, 2, 3. And then what I'm doing is I'm creating a key, K, and that key will correspond to the column heading, and a value which corresponds to the value in the row that I've just looked up. Okay, so really what I'm doing is I'm saying column heading link, column heading link, column heading link, or potentially column heading no match. All right, and then because I don't want it to be visible in the classifier, I'm just adding this exclamation mark to the beginning of my column heading. Okay, so creating some metadata here. Then what I do is I take my subject, I take its existing metadata, which if you remember is a Python dict, and if you know about Python, you'll know that Python dicts, you can update them by calling update, and I just pass in this extra data, and then I resave my subject. Okay, so let's see if this works. So it's going through, should be slightly faster, we shall see. And then while that was quite fast. So now hopefully we can go back and check if that's worked. Now, in order to check if that's worked, we may be able to do it here, but I don't think so. Let me really quickly have a look at that. Yeah, so we can't see it here because this is behaving like it was the classifier and not talk. So what we're actually going to have to do is view our project to check that this has worked, get started, classify something. This looks a little bit like a pulsator to me, and it's at the wrong period. And then if we go to talk and talk about this, keep your fingers crossed. If I look at the metadata, I see. Well, this particular one, of course, had no match, but you can see it's added the extra metadata for, I don't even know what this acronym stands for, the Sinbad catalog, and then the Assassin Photometry catalog here as well. This one had no match. If there had been one with a match, there would have been a link. So an unfortunate example, but subjects are served at random. All right. So that's how you update metadata to basically give extra value to your volunteers. It's also going to be useful to know how to update metadata because it's going to be useful when we set up feedback later on. So another really useful thing that you can do from Python, as opposed to doing from the project builder, is to download classification and subject data. And that can be really useful if you've got a Python script that you're trying to run to process your classifications, and you don't want to have to go through the rigmarole of going to the project builder. I mean, it's not that bad. Going to the project builder, going to exports, where the data exports, clicking request new export, and then downloading your data, especially if you already know that you have a perfectly good data export available. Okay. So what we can do is we can use the fact that both the project and workflow classes that we got from the Panoptes client are what are called exportable. Okay, and that means basically that they both have this method called getExport. Now, for both project and workflow, you can request two types of export. You can either request an export of the subject data, so you would specify subjects, or the classification data, in which case you would specify classifications. The getExport method also has a few other arguments that you can pass in. So the first one is generate. Okay, if you specify generate, what that means is that even if there is already a data export available, it's going to regenerate it for you. And if there isn't one, then it will generate one for you. If you specify that it's false and there is one there, it will just get the one there that's already existing. And if there isn't one there, then it will fail. The method will not return. Well, it will return, but it won't return you any data. The second argument is to wait. So if I specify generate, for a big project with lots of classifications or lots of subjects, that can take a little bit of time. Okay, so I can decide, do I just want to say, okay, generate me a new data set, and then I'll come back and run this code again later, in which case I probably don't want to wait. I'll just generate and then come back later. However, if I think it's going to take a short amount of time, then I can say, no, it's okay. I'm willing to wait for that generation to happen. And maybe 15 seconds later, as soon as my export is ready, it will start downloading it. At the same time, you will still get that email that you would have got if you initiated the generation through the project builder. And then finally, wait timeout is just, you can specify the maximum amount of time that you're willing to wait. And that's specified in seconds. Okay, so here is how we would get the classification exports for our project using Python. Now, if we just jump back here, you can see that I actually know that I already have a classification export that's available to download, so I don't need to regenerate that one. But the subjects, I don't have those ready, so I would need to regenerate that. And since we only have a few subjects, I'm hoping it won't take too long. But what I might do is just change wait to false there, because I'd quite like to get on with the demo. Okay. So let me run that. It's going to take a little bit of time. Tick tock, tick tock. And then once that's finished running, hopefully, what I'll be able to do is have a look at those classifications that I've downloaded. So what we will get down from Panoptes is what you would have got if you downloaded it from the project builder, and that's basically a CSV file, so comma separated variable file. What these lines are going to do, they're going to read the raw response that I got back from Panoptes, which is actually a type of object called, it's called a response object. And if you were to just look at it, it would be quite meaningless. So I advise you either to understand this code or just copy this code. But what I'm doing is I'm getting the content of that response object, which is basically raw CSV data. I'm converting that into a type of object that pandas can understand using read CSV, and then I'm reading it into a data frame, which is basically the type of object that I'm showing here, so that we should get a nice table of our classification data. Unfortunately, now I am sort of somewhat beholden to the Panoptes API. What I might have to do is do a quick download later. So I tell you what I'll do, I will come back to that later because I don't think we're dependent on it for the rest of the demo. But I would like to show you that it's worked when it's worked. Okay, so the next part of this demo, let me briefly check how I'm doing for time. I think I'm okay, actually. Okay, this is good. The next part of this demo, I would like to show you how we set up feedback and volunteer training. So this is one of the advanced features that we talked about yesterday. I'm actually going to have to stop that, because otherwise I won't be able to run extra cells. Keyboard interrupt, yeah, sure. All right. And so this is one of the things that, first of all, you don't get it generically in all projects. Okay, so we said yesterday, because it's an experimental feature, the first thing you need to do if you want to use feedback in any project is to send an email to this email address, contact@zooniverse.org, and explain that you would like feedback to be switched on. Okay, once that's done, you'll see a new set of options that are available in the task definition section of the project builder. And luckily, I sent that email last night, and we can see that if we come to our workflows and click on classify like curves, and then this is the task definition area. If we scroll all the way down, we can see that we've got this new option now, which is the feedback option. Okay, and there's one button in it at the moment, which is to create a new feedback rule. We'll talk about that in a second. So once we've done that, well, there are some things to bear in mind, of course, which is that feedback is available for a few of the classification and annotation tools, but not all of them critically. So the ones that tend to get used most often and the ones that we saw yesterday are the ones for the point marking drawing tools. So yesterday we saw examples of both. If you hit within an elliptical region in LOFAR Galaxy Zoo and in a circular region, both in LOFAR Galaxy Zoo and in Galaxy Zoo Clump Scout as well. Okay, and I also showed that it's possible to set up a false positive mode for that. I won't be demonstrating that today, but if you're interested in that, talk to me about it tomorrow and we can get that set up for you. The one that I will demonstrate today is actually for a question task, because all of the tasks in SuperWasp variable stars are single answer questions. And what we can do is we can specify a message that the volunteer will receive if they answer in a way that agrees with the expert, and a different message, which is what they will see if they answer in a way that disagrees with the expert. Okay, so the first step is to set up what we call task level feedback rules. Okay, and task level feedback rules, first of all, you specify what type of rule you're setting up. So is it a rule for a question task or a drawing task? And then secondly, you specify some sort of fallback messages that are going to be displayed in the success or failure cases. Then once we've done the task level stuff, then we can go ahead and start setting up subject level feedback. Okay, and to set up subject level feedback, you need to define new metadata on your subjects that you want to be used for training. Now, of course, because you need the correct answer, these have to all be subjects that an expert has looked at and defined what the correct answer is. Okay, so for all of these subjects, we add these new metadata specifying what the correct answer is and what messages to give if the volunteer gets the answer right or gets it wrong. If the feedback system doesn't find any of these metadata associated with a particular subject, then you get no feedback. It's not an error, it just falls back to normal behavior. All right, so I think what I'll do is very quickly jump back to here, and we will set up a task level feedback rule here in the project builder. So I'm going to click on create new rule, and the first thing we have to do is specify an ID, and this should be, most likely it should be something like an integer. I don't think it has to be. I think generically it's a string. I tend to just use integers, so we'll call this rule number 1. You have the option to enable both types of feedback. We will do in this case, so we'll enable positive feedback. And this is a generic message that will be displayed if we don't specify a specific subject level message using metadata. So we could say if it's positive feedback, you know, we could say great, well done. And if it's negative, we could say something like unlucky. And then the final thing that we do is we're specifying something that they call the feedback strategy. And what this is referring to is basically the type of question that we're trying to set up feedback for. And so there are various ones here. The ones that we looked at yesterday are the radial ones. So that's a point within a circle and the point within an ellipse, which has a sort of more intuitive name. The one that we're interested in today is the single answer question. So we're going to click single answer question and we're going to save that rule. So we now have one feedback rule associated with this task in our project. Okay. So what we need to do now is for every subject that we know the answer for at least, it's going to be one of these. It's going to be one of 0, 1, 2, 3, 4, or 5. Okay. We refer to the answers by their position in this list. Okay, so we need to work out how, with metadata, to specify the answer and potentially a special message that goes with that answer. So how do we do that? Right, so all of the metadata that are associated with feedback, first of all, they're hidden, so they begin with a hashtag. But secondly, they all begin with this sequence of characters, feedback underscore, okay? After feedback underscore, the next part of it is an integer, okay? So 1 or 2, you all know what an integer is, I don't need to tell you that. So it's going to be, the stub of our metadata becomes something like feedback 1, okay? That number, what that allows you to do is associate several different instances of the same rule with the same subject. So I should probably change this sentence, it's not quite clear. Why might you want to do that? Well, let's say I had a rule and it was a point within a circle rule, but I wanted to have the answer be different. So a really good example of that is in Clump Scout. You could have one rule that says a point has to be within 3 pixels of a certain position, but the position could be different. So you would have the same rule, but there would be multiple instances of where that rule is valid. And that's what this number is all about. Now for us, we only have 1. So this is always going to be 1 for our example. But just to be aware, this number is not referring to the number of the rule. It's referring to the instance of the use of that rule for a particular task. That sounded complicated even to me, so I'm expecting questions about this later. All right. How then do we associate our feedback metadata with the rule ID that we set up? Okay, and that's where we put on the final suffix to our metadata name, and that suffix is ID. So this basically is the code that we would need to do to update the metadata to say, okay, we would like feedback on this subject. So we have a particular subject here. We would like feedback to be active. It's the second instance, if you like, of the time that we've used this rule. And we would like feedback to use rule 3 in this case, okay? So for all of our ones that we're actually going to use properly, this is going to be something like hashtag feedback 1 underscore ID and then 1. And as you can see, this is a string. So in principle, that feedback ID could be a string of characters rather than just a number. Okay. Yes, it is indeed a bit complicated. So hopefully it makes sense, and hopefully it'll make sense once we go through a few examples. Okay. So we've associated a subject with a feedback rule using this syntax. The next thing we want to do is we want to specify what that subject's correct answer is. Okay. And to do that, we take our feedback number stub and we add a suffix, which is this suffix, answer. Okay, and what value are we going to give to the metadata that is going to be, in this case, it would be feedback 2 underscore answer. Well, that is the number of the position in that list. Okay, so if the correct answer was pulsator, then we would say 0. If the correct answer was EAEB, we would say 1. Okay, so that's what we're going to put for the value of that metadata. So the example that I've gone here is what if our options were good, bad, and ugly, and I wanted to specify ugly was the correct answer, then I would say something like feedback to answer is 2 because 0, 1, 2. Okay, hopefully that makes sense. And I've reiterated again that this 2 is different to this 2. Right, and then finally, if we're not happy with the generic sort of task level success and failure messages, we can specify specific subject level success and failure messages. Now, as I can think of a couple of reasons why you might want to do that. Maybe you want to incorporate the correct answer into the message. So you might want to say, unlucky, that one was actually a pulsator or something like that. The example that I'm going to go with for this demo is we're going to identify some that we as experts think are actually really hard, and we'd like to give extra congratulations or extra commiserations if a volunteer happens to get it right or wrong. Okay, so what we can do to specify a special subject level success message or failure message is we take that stub again and we use the suffix success message for the success message and error failure message for the failure message. Where are we? All the way down here for the failure message. Okay, so in this one, I've said, this one's a particularly hard subject. So for my success message, I've gone well done. That one was tricky. And for failure, I've said hard luck. That one was very difficult. Okay, so the idea is that, if they got it wrong, they shouldn't be upset about it. And if they got it right, they should be extra confident. Okay, so the correct answers. So I think I've already made the point that you need correct answers to be able to do this. I think it's quite obvious. We've been away for some of the subjects in our subject set, and we've actually compiled a list of correct answers. In fact, we've compiled a list of correct answers for the subjects that we uploaded through the project builder yesterday. So those are for demo set 0 to 10. And in the data here, you can see there's just this CSV file that contains the correct answers. And so I've got my image, I've got the correct answer category, its position in the list, and whether I thought it was difficult. Okay, so we're going to use these data to set up our new feedback metadata. Okie dokie. Right, so I'm going to read in the correct answers. There they are, we just saw them. And I'm going to, because it's a slightly complicated task, I'm actually going to create a function that's just going to make the dictionary that contains these metadata. Okay, so I'm going to pass in the answer. I've set the rule and number to be settable if you want to, but as I've already said, for us, we only have one rule and we only have one instance of that rule, so it makes sense for them both to be 1. So that's why they're defaulted to 1. I'm creating, first of all, a default set of feedback metadata. The ones that we talked about, feedback number underscore ID, and then the rule number that we've specified, and then feedback number underscore answer, and then this is the answer, and then the category position. So here, category position. So it's going to put one of these in. Okay. Right. So that's that. If the answer is difficult, so if this is true, then I'm going to add 2 more extra ones, which are my special messages. Well done, that one was tricky, or hard luck, that was difficult. Okay, and then I'm going to return this assembled dictionary. Then I'm going to do what we did before when we were just adding value to our subject set. So you've seen this code before. I'm going to go through our subject sets and our subjects. I'm going to get the image ID out again before. Then I'm going to say, well, okay, if my image ID is now in this list, then I know the correct answer and I'm able to set up feedback. So we're going to set up some feedback. So then it does it, and it's going to take the subject and metadata, and it's going to update it. It's going to call this function here. It's going to extract the row from this table that it found, and then it's going to pass that through here so that we can work on it, and then it's going to save the subject again. So This is an advanced feature, so it is quite complicated. However, I guess from your point of view, if you want to do it for your own project, you really wouldn't have to make much modification to this code. You could just copy and paste this code and it reasonably well. So let me try and run that code.
Quick question while that's running.
Go for it. He says.
For the ID and the answer, the metadata, does that have to be a string, or are they entered as, it looks like you have them entered as strings, but before the answer was as an integer. So I just want to check what the data type, expected data type for that is.
Right. So I've actually been and looked at the background sort of Panoptes code, and it chops and changes. So there have been bug reports filed that it should be able to be both. At one point in the past, it was a string and it didn't work if it wasn't a string. I think maybe now it could be either, but I'm erring on the side of caution here. Now, what I don't have, what's going on?
You're missing a comma.
A comma. Yeah,
yep.
Got it. Thanks, Coleman. Brilliant. So actually, that's a really good point, because this is the one thing that I didn't mention. There's one extra hidden metadatum here, which is training subject. What that's used for is later on, we're going to, in Caesar, we're going to say that certain retirement rules should ignore training subjects. And this is one of those special metadata that Caesar reducers can pay attention to, okay? So if you have a subject that you want to use for training, and you want Caesar to ignore it when it's applying certain retirement rules, you should add a hidden metadatum to that subject called training subject and set it equal to true. Okay, so that's what that's for. All right, so I wonder if we can do a quick test on this. Right, now the problem is, yeah, it should work, I think. Right, so we've updated the metadata on our demo subject set, hopefully. And if I come to workflows and classify light curves, and let's try this again. Let's test this workflow. Watch it spin, and let me get a wrong answer. Keep your fingers crossed. Yes, we get our feedback. It's telling me, well, this one, I didn't think it was hard because it was so obvious it was junk. So we get our generic message, and it says unlucky, and the one match is just part of the interface, because in principle you could have many unlucky matches. Okay, let me go back, click on junk. Oh, that's not good. What did I think it was? Anyway, okay. There had to be one failure in this. I wonder what I thought that was. Okay, let's go on to the next one, and let's try. Great, well done. Okay, so obviously I thought this one was hard, and apparently I got it right. I'm actually looking at it, not convinced that I got it right, so I get the special message. And those were the two things that I wanted to, actually, no, that's the generic message as well, isn't it? Eventually, I could get to the special message, I suspect, but let me try one more. This one, yeah, let's try that. Yes, okay, finally, a special message. So this one was tricky, and when I classified it, I thought it was probably in the AEB. All right, so that's what I wanted to show. It seems like potentially, apart from that first one, that I really thought was junk, but wasn't. Okay, so the final thing, let me do one more time check. Yeah, we're doing okay. The final thing that I wanted to show, I think it's the final thing, is how we set up tapered feedback, okay? So at the moment, all of the subjects in that subject set have feedback, and so there's only one subject set that's associated with that workflow, so we're going to get feedback for every single subject. Yesterday we talked about how that might not be the best way to go. What you might want to do is have more feedback at the beginning when volunteers first join the project, and then as they get more and more confident, they see less and less feedback, because eventually it's just going to become annoying for them. Like, why are you telling me this? I know that was the answer. I'm really good at this. Okay. The thing that's really important to bear in mind that I already mentioned yesterday is that this tapered feedback approach will only work for users who have a Zooniverse account and who have logged in. Okay, and that's because it relies on knowing how many classifications a particular user has submitted. If they haven't logged in, the system can't really know that very accurately. Okay, so how does this actually work? Well, we talked about this a little bit yesterday. Technically, it works by controlling how frequently subjects are selected from different subject sets. Okay, so what you would do is you would make two subject sets or two sets of subject sets, and set of subject sets, all of your subjects would have feedback metadata, so they would be your training subjects. And in your other set, none of the subjects would have feedback metadata, so they would just be normal subjects and they would not display feedback to the volunteers. So yes, I've written something. Luckily, we actually have two sets and only one of them has feedback metadata associated with them. So what we can do is we can set it up so that when the volunteer is going through subjects, the early ones they see will be selected mainly from the set with feedback metadata, and then later on they will be selected exclusively from the one, eventually exclusively from the one without feedback metadata. And the way that we do that is by modifying attributes of the workflow configuration. Okay, so Zooniverse workflows, like subjects and also like projects and things like that, are represented by instances of what's called the workflow class. Now, you may remember that I didn't import the workflow class way up at the beginning. I don't actually need to do that because I can just get a reference directly from our project instance like this. So again, this brilliant project links workflows. We actually only have one workflow associated with our project, but workflows is a list because in principle you could have more than one workflow. And so I'm going to select the first 0th element of that and print its name, and hopefully it should say something like classify light curves. It does say something like classify light curves, which is great. Okay, and now we need to edit its configuration. So this workflow object has an attribute called configuration, and that configuration is again a Python dictionary. And we need to add 3 new keys and values to that Python dictionary. So the first one of those, we talked about this yesterday, is something called training set IDs. And that's the list of subject set IDs from which, basically it's the list of subject set IDs that contains subjects with feedback metadata. Okay, you don't need to specify a separate set of IDs that don't have feedback metadata. The second thing that we need to specify is this thing called training chances, and that's another list, and the number of elements in that list is basically the number of classifications that you want to control the frequency over. Okay, so let's say you want to control the frequency over the first 20 classifications. That list will have 20 entries, and each one of those entries is a probability, so it's a real number between 0 and 1. If the number is 1, then it is, well, it's complete, it's guaranteed that the subject selected for that classification will be a feedback subject, will be a training subject. If the probability is 0, then there's basically 0 chance. Now, there's some caveats around that you can ask me questions about if you want to. Mainly for efficiency reasons, they load subjects in blocks of a certain size, so you can't guarantee it super finely, but in general that's the rule. And so, for example, if it was 0.5, there would be a 50-50 chance that you would see a training subject or a normal subject. And then finally, what happens when you get to the end of this list? So in my example, there was 20. When you get to the end of this list of 20, you fall back to what's called the default chance. Okay, and most normally, unless you think that a volunteer would really like to just every now and then have a little bit of feedback, so you could set it to a very low number, normally you would just set this to 0. Okay, and so once you've exhausted this list, you've tapered down to 0. Everything after is just 0, so you'll never see another subject from the feedback sets. Okay, so that's what we're going to do here. We're going to say our workflow configuration training set IDs. We're going to, what have we done here? Okay, so all I've done here is I'm going through my subject sets, finding the one that has the name, in this case, demo set, but that's not going to work because I made a typo up here, didn't I? Subject sets. It should be called demos subject set. Demos subject set. So now when it finds that, it's going to add that to my list of training set IDs. And that's good because this particular subject set has all of my feedback subjects in it. Then I'm going to set up my list of training chances. And so what I'm doing here is I'm saying for the first three, I would like 100% feedback. For the second three, for the second set of three, I would like 50% feedback. And then my list runs out, so I've only specified it for these first few. Thereafter, I don't want to see any more training subjects. Now, one thing to bear in mind is that because these training subjects there'll be fewer of them than normal subjects, and volunteers are always going to see some of them at the beginning, it's likely that if you set it up with the standard retirement rules, so 5 volunteers see it, 10 volunteers see it, they're going to retire much more quickly than your normal subjects, just because they'll be shown to volunteers more often. And so we need to stop them retiring, because what you'll find is eventually training will just stop happening. And so how you do that is you set up one more thing on your workflow object, which is you set this retirement attribute. It's also a dictionary. You set its criteria key to be equal to never retire. And then once you've done that, you need to set up Caesar to retire all of your non-training subjects. So you need to set up special rules in Caesar to do that. If I have time, I will show you. I've unfortunately run out of time, but this is definitely something that's quite straightforward to do, and I can show you how to do that either tomorrow or later today if you ask me a question. So let me just make sure that that works. And that works. And that is the end of this tutorial. So thank you all for listening. I hope I haven't confused you too much, and please ask questions if you have any.
Hi Hugh, I've just got a question about where this is available, because obviously it's on the GitHub, but is it anywhere that's accessible on the Zooniverse site in any way, or some hidden documentation I might have missed?
So this is not well documented. In fact, this is probably the most comprehensive documentation I know about that exists. I will talk to people at Zooniverse, and we could get this linked from the Zooniverse website and maybe take the code out. If the code is, just talk about the generics of how you would do it, if you think that would be useful. Because it's an experimental feature, in particular the feedback is an experimental feature. I'm assuming that's probably what you were talking about. That's not very well documented. On the other hand, the Panoptes Python client written by Adam is very well documented, and maybe I can find that documentation for you really quickly. Grand. All of that documentation is available here on read the doc. So all of that stuff that I was talking about in terms of workflows and projects and things like that, that's all documented here. So that's good news.
Great, thanks.
All right, no problem. Any other questions, or just general confusion and panic? But Coleman is from Portsmouth University, and he's very kindly agreed to give us a tutorial on aggregation and working with Zooniverse data. Take it away, Coleman.
Yeah. Hello. I'm Coleman Krawczyk. As he said, I'm working at the University of Portsmouth, and this data aggregation engine that the Zooniverse uses. This is actually something that I've written, so I'm going to be presenting what's called the Panoptes aggregation package. So it kind of goes alongside the Panoptes client. So this is for doing data aggregation. This is a pip package. So just like any other Python package, you can just pip install Panoptes aggregation. If you're not comfortable with the command line, there's also a optional user interface that you can install if you add on the option GUI to the end of that. Today we're going to be working with the command line just because that fits inside of a Jupyter notebook better and works better for demonstrations. But everything I'm doing here can also be done through this GUI. In general, the documentation can be found at this link. So I can bring over to this tab. So everything's documented here. There's full installation instructions as well. One small side note, if you're working with an Anaconda build a Python and you're on a Mac and you want to use the GUI, there's some extra steps to actually make that happen because Python versions on Macintosh are a little weird, especially with the Anaconda end of things. But it's all in the installation instructions within the documentation for getting started. First off, I should say all of this sits inside of the aggregation tutorial within the GitHub page for this workshop. This has all the example data that we're going to be working with inside of it and the folder structure that we're going to be saving our results into. This is all going to be done in what we call offline mode. So it's all going to be local on your computer running it. So feel free to follow along with these notebooks on your own computer. If you're running it on your own system, you're going to want to run this line first to install the Panoptes aggregation package. Or if you don't have a working version of Python, I've included some instructions for getting this notebook up and running on Google Colab as well. So you can upload it into this entire example folder into your Google Drive and use Google Colab to directly run all of this Python code on Google servers, and you don't have to worry about how do I get Python installing on my local machine. There's a couple of things you have to do to actually connect up and get your Google Drive mounted so you can read the data and make sure that the code's running in the right folder. But there's step-by-step instructions up here. I'm running this locally, so I'm not going to be running these 3 cells here at the start. Just to give a little bit of tie-in, so this is the Panoptes aggregation package. It ties in with the Caesar system, which I think you got a brief introduction to yesterday. But the idea of Caesar is it's a system for doing data aggregation live on a project. So as classifications come in on your project, it automatically runs a series of steps to take the relevant data out of those classifications, take all of the classifications for a single subject and combine them together to give you some form of consensus, and then has optional rules that you can set up on those consensus to then trigger effects such as retire a subject or move a subject between workflows, or really anything that the Panoptes client can do can be a rule triggered by Caesar. Or it can actually trigger an external website as well. So if you have your own data server where you want to store aggregated results after they've retired, you can set it up to feed directly, basically send those results off to your local server or whatever system that you want to. But before we dive into setting it up, things on Caesar, it's always good to run things locally to get an idea of how, or to figure out how the data aggregates, to figure out your best parameters for the aggregation. So tweaking some of the little knobs that you have access to give the best idea of consensus for your tasks that you've set up. And all of that comes off of your data exports from the Zooniverse project. So the main exports that you need to get started are a classification export. This can either be for your entire project or a workflow specific export if you want it for just a single workflow. This comes down as a CSV file, and the main columns that are inside of it are a classification ID. So this file has one row for every classification made on your project. Classification ID is the Zooniverse unique ID given to that classification. Username is if the user or volunteer is logged in, this is their display name. If they're not logged in, this is a hashed version of their IP address. The full IP address is provided for privacy reasons. Then there's the user ID column. So again, if they're logged in, this will just be their user ID number. So if you want to make sure username, since it's a display name, there can be potential collisions. So user ID is a unique identifying number. Plus username, something that the volunteer can update in the future, but their user ID will always be constant. User IP address. So again, this is a hashed version of their IP address if you want to try to do location-based things. So if you have a feeling that a bunch of classifications are made at a school in a shared lab, you can try to, pick out everything that was made off of a common machine with this column. Workflow ID is the ID number of the workflow that classification was made on. Workflow name is the display name that you've chosen for that workflow. Workflow version is the major and minor version numbers of the workflow. So a little bit on version numbers. When you set up a project, you'll actually see the version number down here for this example. This is version 4.5. The major version, so the first number of this, increments anytime that the task physically changes. So if you add an answer to a task, or you change something from a drawing task to, say, a question task, or add a new task, any of those operations will increment the major version number. But if you only change text, so anything that's in a text box within the editor, that will increment the minor version number. So you can use this to help track when major structural changes have changed to your workflow. That typically means you're probably going to have to run it through a completely different aggregation routine or a different aggregation configuration because new tasks were created, or if it was just minor text changes, which typically can be run through the same aggregation code. Over to this. So that's your workflow version sticks around, so you know what version that classification was made on. Created at is the UTC timestamp for the classification. Gold standard and expert, these can be a little bit confusing, mainly because we started changing naming conventions partway through building Panopti, so things that were very similar got very similar names. Gold standard is what Hugh was showing earlier when a subject's identified as having a correct solution through its metadata. So if you have this feedback system set up, something that would provide feedback is going to be marked as gold standard in the system. So if this classification was made on one of those subjects with feedback, this gold standard is going to be true. Whereas expert mode, if you're a project owner or you are given a project role of an expert, you have the option when making classification to click a little checkbox that says this is in expert mode, and all that checkbox does is add the flag true to the data export. So if you have a set of collaborators that you just want to know which subjects those collaborators classified on, you can tell them classify in expert mode, and you'll be able to identify those through the classification dump. The aggregation, as we're going to be running it today, actually does not use either of these columns. So it's mostly going to ignore these, so nothing's going to be done with them. But in the future, these, we're working on ways to incorporate these in to do more sophisticated things like volunteer weighting. So using that feedback to then figure out which volunteers are doing better than others and have that incorporated into aggregation. But none of that's been written yet, but those are the plans. There are plans for that. Next, we have the metadata column. So this is a JSON blob. So JSON is JavaScript object notation. It's essentially like the Python dictionaries that he was talking about earlier. It's just a group of key value pairs. And this metadata, this is metadata about the classification. So this includes things like the browser size, browser user agent, classification durations, and a whole bunch of other information specific about the environment in which that classification was made. So if he ends up being a bug and you want to know which classifications were made on mobile devices, this is where you would go to find that type of information. Annotations. This is the meat of the classification dump. This is where most of the interesting information is. This is again a JSON blob or a dictionary that contains all of the clicks or annotations, all of the answers to each of the tasks that the volunteers made on the workflow. So this will be contains every task within the workflow in a single object. And the exact shape of this is dependent upon the tasks that you've created on your workflow. So if it's question tasks, that has a certain structure. If it's a drawing task, that has a different structure. Survey tasks, yet another structure. And those are all strung together depending on what order those were answered in. Subject data. This is a JSON blob that contains the subject metadata. So all of that metadata that we were creating with the command line in the previous section or previous workshop, that would all come along inside the data dump as well. And you'd have all that subject metadata directly lined up with the classification. So you don't have to match it to the subject export if you don't want to. So you can grab all that information. The one nice thing about it sitting here is it actually comes inside with the classification data during aggregation. So if you want to set up, use the aggregation system to write your own custom code within its framework, you do have access to the subject metadata during the aggregation step. So you can pull out information like the gold standard answer if a subject had feedback set up on it. You can pull out this was what the right answers were. And then finally, a column of subject IDs. So this is just the Zooniverse subject ID number for the subject that was classified on. The next major export is the subject export. Again, this is a CSV file. But this time there's one row for every subject uploaded to your project. The main columns of this are the subject ID. So this is the Zooniverse ID number that's given by the Zooniverse. This is not your own ID number that you might have for identifying the object. That's going to live inside the metadata if you've included that inside of your metadata. The project ID is the Zooniverse project ID number that the subject's associated with. The workflow ID is the workflow number that subject's associated with. If a subject is associated with multiple workflows, so you have the same subject set activated across multiple workflows, that subject's actually going to show up multiple times as multiple rows in this file. So it's actually going to be the unique identifiers, the subject ID, along with the workflow ID of this table. Subject set ID is the ID number of the subject set that subject belongs to. Metadata is any metadata that you uploaded with your images. So they would come along as a JSON blob or essentially a dictionary inside of the CSV file. Locations, this is a JSON blob for each frame of your subject. So frame in this case means if you uploaded multiple images to the same subject, when that's displayed on the project, it'll be multiple images that the volunteer can flip through when classifying. So each of those is going to have a URL to the uploaded image, and this locations object contains one URL for each frame of the subject. This is particularly useful if you've somehow lost your source images and you want to re-download the images that belong to that subject set, and you want to have exactly the ones that were shown to the volunteers, that URL is saved in this export, so you can re-download those images if needed. Classification count. This is how many volunteers have classified that subject. So this is, again, because this is paired up, the same subject is in here for each workflow it's on. This is the classification count of that subject for a particular workflow. So yeah, you have the classification count. If the subject's retired, it will have a retired timestamp. So this is the retired at column. Again, it's a UTC timestamp. And the retirement reason is marked as what reason was given for that retirement. If you don't have anything set up through Caesar, this is just going to be a classification count. Or if you've set it up to never retire, the retirement, well, it would never retire, so these two columns would actually be blank. But if you set it up through Caesar, there's a set of retirement reasons that you can set, such as blank or unclear or other things like that. And this is just a way of signaling. You can figure out quickly which ones were retired under what rules. And then lastly, we have the workflow export. So this, the aggregation code uses this export to figure out the structure of your workflow, to do a bit of configuration. So to try to figure out and set up how it should aggregate your data together. To do that, because it needs to treat question tasks different than drawing tasks, different than text tasks, it needs to know what tasks were asked and in what order. So, or actually, no, order doesn't matter. Just what questions were, or task types were asked. And it does that by looking at your workflow export. So within this CSV file, you have a workflow ID and the display name of the workflow and the version. There's one row for every major version of your workflow. So a row will actually be updated for minor workflow versions. So any text changes won't create a new row, but actual adding of tasks or removing of tasks will. A column called active, which is either true or false, depending if that workflow is currently active on the project at the time of creating the export. Classification counts is how many classifications have been made on that particular workflow. Primary language is the language in which you wrote the workflow. This is going to be English for all projects, unless you've specifically set up the experimental translations. And doing that is set up through contacts at Zooniverse. You email them, you can figure out how to set up translations for a project. But this is, in most cases, going to be English. The first task is the task ID number, or the task key for the first task of your workflow. And task key, so if you come over to the editor, is this little number right here. So when you add tasks, so for example, on this project, I have one drawing task, it's task T0. If you add another task, it will increment. Next one will be T1, T2, T3, for however many tasks they are. So when you set your first task here, so this drop-down list says the first task is T0. That is saved within the workflow object as the first task. This is useful for knowing what's the entry point. So where do you start when traversing the task structure? This column, retired set member subject count, is just a fancy way of saying how many subjects are retired within that workflow. Tasks. This is the actual structure of your workflow. So every task type has a very specific, particular structure here. This is again saved as a JSON blob within the CSV. And this is what the aggregation code is going to do to set up its auto configuration. So it's going to look down your task list, figure out all of the task types, and set up how to take that data and how to combine it. Retirement is the retirement rule for the workflow. If you're not using Caesar, this is going to be typically classification count or if it's a subject that's set up with feedback, this would be never retire, or if it's set up through Caesar, it's actually also going to be never retire in here. So the Caesar rules don't sit within this export. Strings. So this other column, this is actually the text that's inside of your workflow. So if you were to look at the task structure, what you end up seeing is, for example, here you would see T0 question.label, and it won't actually say explain what to draw within that structure. That label is actually located inside this string JSON. So this will actually point to a key inside of this object to then pull out the actual text that was asked. The reason this is kept separate is to enable translations on a project. So if you have multiple languages, all you have to do is create a new strings object. You don't have to actually create an entire new task structure. You just have to change what where it's referencing. So for that reason, all strings are actually kept in a separate location, and that's this column. And then finally, you have the minor version, which contains the minor workflow version. So the major version is kept up here, whereas the minor version is kept in the final column. So this is just to give you an idea of what's inside of these data exports. So if you need to do any custom work with them, you have an idea of what data is presented back to you as the researcher. But a lot of this we aren't going to have to look at directly. We're just going to be letting the aggregation code take over and walk through these files and do the aggregation for us. So to give you a little bit of background with how aggregation works and in general how Caesar works. So this is set up into a three-step process. So the first step is a configuration step, where we're going to be looking at the workflow data dump or workflow export and figuring out what extractors and reducers we want to use. And by extractors and reducers, what I mean is the second step is where we extract the data out of the classification data dump. So we go row by row and we say, find every drawing task and grab all of the drawn points and save that to a CSV file. So that's an example of an extract step. Or if it's a question task, save out the answer that the volunteer gave. Or if it's a text task, pull out the text that they wrote. The reduce step takes all of the extracts for a particular subject and then combines them together to give you a consensus value. And that consensus is very much dependent on the task type. So if it's a question task, it's going to return vote counts for each answer. If it's a drawing task, it's going to return clusters of points. So how many points were drawn close to each other. If it's a text task, it's going to return what's called an alignment table. So take the text strings that multiple people wrote, split them up by word, and then try to align those together in a way that would then give you a consensus sentence. So to kind of explain these three steps, we're going to set this up and we're going to work with some Penguin Watch data. So this is real data taken from the Penguin Watch project. I took, I think, about 10 or 15 images, took all the classifications for those and created mini data dumps. You can find those in this Penguin Watch example data dumps folder. So if we look inside this folder, if my computer will let me, there we go. We see 3 CSV files. These are the 3 files I was talking about up here. So we have the classification data. This is a trimmed version because it's only for a certain number of subjects. And we can see all those columns I was talking about. And we can see how the annotations are stored inside of this data. And we have our subject metadata, subject IDs. So we have a large CSV file here. The subjects, we can go in, we can see all the subject metadata, the locations, so the URLs for each of the subjects, when they were retired, and why. So this was set up with Caesar, so the retirement reasons are going to be their classification count or nothing here. So this is what we call early retirement. So basically, if the first 3 people on the project said there's nothing in the image, it gets retired early. Otherwise, it waits for 10 classifications. And then the actual workflows, this is their workflow data dump, so we can actually see their full workflow structure if we wanted to look in here. Like I said here, it just says things like label T6 answer 0 label, but doesn't actually contain the string. That's actually contained in the strings column, where you can actually figure out what that label belongs to. But the aggregation code makes that a little bit easier, as I'll show. And I've also included Penguin Watch subjects. I included a selection of penguin images directly from the site, so you don't have to re-download them. I'm just going to leave this one open here for a second because we're going to come back to this. So back to our example. So in order to start processing this data, the numbers that we're going to need is we need to know what workflow that we want, the workflow ID that we want to configure, and the workflow version that we're looking to configure as well, alongside our data dumps. So for this example, the workflow ID is 6465, and the version is 5276. So this all of the Panoptes aggregation comes as command line routines. And if you're confused about what you can do at any of these stages, you can always do -H to get help text explaining all of the inputs. So the first step we're going to do is configure configure up our extractors and reducers. So this is an auto configuration step. So it's going to take its best guess at the configuration. But we're going to have to go in and edit these configuration files by hand to get exactly what we want and to get better results. But the idea of this is it's going to give you a good starting point for all of your configuration files. So the command we're going to run is Panoptes aggregation config. Then we point it to the workflow export. So it's one folder down, and it's our workflow CSV. Workflow ID number 6465. -V for the major version number of 52, -M for the minor version number of 76, and the -D do you want to save the configure files in. So to keep our file structure clean, I created a folder called aggregation results that we're just going to direct all outputs into that folder. So going in there right now, this folder is just has another empty folder inside of it that we're going to be using a little bit later. But if I run this command, you'll see it outputs, it tells us that it's saving an extractor configuration file and what folder that's in. And then it saves 3 reducer configuration files. And I'll explain where those 3 come from here in a second. And then it creates a task lookup table in a final file. So there's 5 files that are created. These are what are called YAML configuration files, so they're human readable files. So for example, let's take a look at our extractor configuration. So our extractor config, let's open that up. And here we see what the auto configuration came up with. So I'm going to try to read through what this is telling us. So within the extractor configuration, it found 3 separate task types within the project. It found a point drawing task that it's assigned to the point extractor by frame. This name is going to be changing soon in the future. I'm going to be changing the autoconfig to something different. But for now, this is a fairly verbose name. But this is telling it was drawing points, so we're going to use a point extractor. There was 2 question tasks. They're going to be using a question extractor, and what's called a shortcut task that's going to be using a shortcut extractor. Within these, you have several attributes. One of them is the task, which gives the task ID for that configuration. So the point task is task T0. The question tasks are T1 and T4, and the shortcut task is T6. So again, these ID numbers are associated with this number here within your task list for the workflow. And if you forget which questions those line up with, you can look in this task labels a file that was also made by the configuration to get the exact task text for each of those. So the instructions for T0 was the string for each penguin in the image, select adult or chick, etc., etc. For tool 0, there was, or for T0, there was 3 different drawing tools, one for adults, a different color for chicks, eggs, and a section for other. And if you picked other, there was actually a subtask, a follow-up question, asking you to pick from 4 different answers. Task, so the image is too dark or blurry. And then you might notice something interesting. The question for T4 was enter a question. The reason for this is they set up a T4 and then never hooked it up. So it was an accidental click on the website. So no one actually made a classification because nowhere in the workflow does it point there. Because I know this, I know we're going to not be working with T4, so I'm just going to delete it out of the configuration file. So here you can actually edit what you're going to be working with your aggregation. So to cut down on some of the complexity, I don't want to be working with that sub question, that subtask on the drawing task. So I clicked other, there was a follow-up question. I don't want to deal with those. So I'm just going to delete these 3 lines here. So within Zooniverse terminology, subtasks are referred to as details. We're just going to remove those. And just to keep this, bring that up. And that was the other task. So I don't want to worry about clustering those points as well. So I'm specifically going to remove tool 3 from here. So again, this was set up with multiple point drawings here within a single drawing tool. So for example, let me bring up or test this workflow. So here's just another test workflow I was working with. But here's an example where you have 2 different tool tasks, one green, one blue. These 2 here would show up in this configuration as tools 0 and tool 1. So again, the order is the order in which they show up in your workflow. So the order here, 0, 1. Because, I don't care about the other task, I'm just going to remove that from the configuration just to make things go a little bit faster. And then I'm going to save the results. So here is our new configuration file. And what this is going to do for each of these task types, it's going to create one CSV file that just contains the information from that task. So we're going to have one CSV file that's going to contain all the drawn points across these 3 different tools. One CSV file that has the answers to the first question that was asked, and all of the another CSV file with all the answers to this shortcut task. So now that we've edited that configuration file, here I'm say all of that in words, we can then run our extraction step. Now, if you want to set this up with Caesar, so this is going to be done automatically on the project, so with the live data coming in, this configuration file is going to help you write your Caesar extractors. So over here in the Caesar interface, this is found at caesar.zooniverse.org. So you can log in with your Zooniverse credentials. The first thing that you want to do is go to the workflow tab and add your new workflow. So here you enter your workflow ID. So this is done on a workflow by workflow basis. This isn't done on a project basis. And I'm just going to quickly go back to where I was. So the workflow I was looking at. So this is workflow 4084, which is this example workflow here that I have open. So 4084. So it has one drawing task. For the extractor set, so again, you can see they have extractors and reducers. So it has those same setup that the aggregation code has. This was done on purpose so that these two can work with each other. For extractors, what we're going to be doing is creating what's called an external extractor. And it's going to ask three different things. A key, this is your own internal key that you're going to be using. So the reducer step is going to be referring back to this. So you can just create this. So we're going to say T0. And then the URL is going to be constructed based on this configuration file. So this Python service is actually set up online. So you can access all of these extractors through this URL by hitting up this server through the extractors endpoint and then entering an extractor name. So here, the extractor name, example, point extractor by frame, question extractor, or shortcut extractor. So there's three different ones that would have to be set up for this project. Then you do a question mark to pass in various parameters on this URL. The first one is going to be that task ID, so task T0. And then additionally, I actually have to update the GitHub repository to include this. I just realized this, right before I started. You also need to pass in a list of what tools to extract. So in this case, we're only going to be looking at tools 0, 1, and 2. So you'd pass that on. So for this example, the point extractor would be set up with this external URL. So we hit up the extractors endpoint, name of the extractor, pass in a task key, and then any other query parameters that happen to be in this extractor file or in this configuration file just get tacked on right at the end. And if we kept the details there, that would be one more thing added on to the end of this query. This example is a little bit easier here, so I'm just going to go back because I've already set this up for this workflow. We can see the URL that I set up. In this case, why is that pointing to the rectangle extractor? That should be a point extractor. Well, T3. Looking at the right. Bad example. Let's just ignore that. That was not set up correctly in my test. I was changing a bunch of things. I should have checked that earlier. But you can set up your Caesar external extractors based on this configuration. And you would set up a different extractor, one for each of the objects in this configuration. Then you also have to enter a minimum workflow version when setting up your extractors. So in this case, we're going to be setting it up to 5276. So it pulls out all of the correct classifications. And then click this Create External Extractor button. So that's how you would set up the same system within the Caesar infrastructure. But going back to offline mode here, running things locally, let's actually run the extraction step. This is going to take our classification CSV file and the configuration file from above and pass it into the Panoptes aggregation extract step. So here we pass in first, we pass in the classification CSV file. So we point to where that's sitting in our subfolder. Then we point to our configuration file, which is in the aggregation results subfolder. So this is the YAML file. -O is just a name that it will append. I'm going to append example to each of the names. So if I run this multiple times, I can give a different name each time. And again, point it to this aggregation results subdirectory where we're going to be storing the resulting CSV files. So we're going to run this step here. And this is going to result in 3 different CSV files being created, one for each of the 3 extractors above. So there we go. So we got a little progress bar while this was running. And now we have 3 CSV files. So let's take a look at one of these. So let's look at the question extractor, because this will be easy to read. We have basic information about the classification, the volunteer information, workflow, the task number that was being extracted, our subject ID, which extractor was used during it, and then all of the possible answers that could be given. So for this sample, there are too many to count, or yes. So the exact question was, did you count all the penguins in the image? So you can basically say yes or no. And this gives one tally mark in whichever answer you gave. And then finally, what's the version of the Panoptes aggregation code that was used to process it. So you can tell, if there was a bug in the code, you want to be like, oh, aggregation version, 2.5 had a bug, so let's ignore those. You can do that as well. But also you'll notice that the order of these columns, it can sometimes be a little bit random. So be aware that every time you run this, this column order might be slightly different every time. That's just a result of how Python dictionaries are unordered objects internally, but that's beside the point, really. Then we can look at what the shortcut extracts look like. This looks very similar to a question extractor. So basically, there's only one answer. It's either the image is too dark or blurry, and they either said yes or no to this. So anyone who said yes will get one tally vote in that column, and it's left blank otherwise. And then for the point data, there's a little bit more structure to these, mainly because every volunteer can draw multiple points and across multiple tools. So for example, here's what the first person, here's a list of all of the X positions that they drew for tool 0, and they drew a lot of them. Here's all the Y positions for tool 0, they drew a lot of them. And then X and Y positions for each of the tools available. So in this case, we're looking at 3 different points they could draw, which results in 6 different columns in the extracted data. So now the final step is, how do we then determine consensus? So looking at these, so our penguin image could be this one here, and we have a bunch of penguins, and a bunch of volunteers have come through and drawn a single point on each of these penguins within the image. And the question that we want to ask is, how many penguins are in the image? So what we have to do is a process called data clustering. So we want to find where there are a bunch of points that are next to each other, and identify that as a cluster. So this can be done in one of 2 different ways. So if we take a look at our, hold on, I need to expand this column. There it is. So if we look at the configuration for the point reducer, we'll see that it set it up by default with what's called point reducer DB scan. But if you come over to our documentation here, and you come down to the section, what extractor and reducer should be used, here's a handy table for matching up a task type with the extractor and potential reducers that could be used for that task type. So if we come down to our point drawing task, we know our extractor was this point extractor by frame. Coming over here, we see there are 2 possible reducers that could be used. One called point reducer DB scan, and another one called point reducer HDB scan. So DB scan and HDB scan are 2 clustering algorithms. So there are 2 that we can choose from here. And the main difference comes with how they handle varying densities of clusters. And what do I mean by that? So looking at this image, there's a lot of depth of field, which means the penguins in the back are much smaller than the penguins up front. So up here, if we look at this penguin, someone draws a point on it, they have a large area to pick from. So that point cluster is going to be at a fairly low density compared to this penguin in the back, where all of those points are going to be really close together. So we have this density gradient from the front of the image to the back of the image. And DB scan specifically sets a single density threshold. So you have to basically say anything that's above this density cutoff is called a cluster. So you're either going to do well clustering the ones in the back and miss all the ones in the front, or grab all the ones in the front all the ones in the back be seen as a single cluster. So you have this trade-off, which isn't very helpful in this case. But HDB scan is an update to that code, or update to that algorithm that does take this into account, and it can allow multiple density clusters to be found because it actually varies that density and then looks at the lifetime of the cluster, so its persistence. So did that cluster survive across multiple different density thresholds? And it has a number that it can assign for basically how long lived is the cluster, and it only gives back the longest living ones. So it actually solves this depth of field issue quite nicely. So for our example, we're going to update our reducer configuration DB scan. Extract tool 3, so we're just going to delete that from here. But also, if we take a look at the documentation for HDB scan, so if we click on this link here, it brings us to the Python documentation for this function. And we see there are various keyword arguments that we passed in that get passed on. Click on to the actual HDB scan website. So this is just another sub-package that's being used. We see that the keywords, we have min cluster size, min samples, metric, p, alpha, and a bunch of other things that we can pass in. The two main ones that we're interested in are this min cluster size and min samples. So we're going to adjust those. Those are the two knobs that we're able to turn to adjust how the clustering works across the image. So in this case, we're going to be setting these to values of 4 and 3 respectively. So I'm going to come over to our configuration file. So any parameters are just going to be tabbed in spaces from the name of the reducer, and any keywords can be added to this. So any of the ones that are accepted by HDB scan can be put in here. So we're just going to now save this configuration file. And out of curiosity, we can take a look at the question and reducer, or the question and shortcut reducer configurations. There are no keywords that can be set for these two reducers since they just do a tally count. So these are just going to be empty brackets. So if you're not passing in any keywords, you just pass it empty brackets within the config file. So those two configuration files we're going to leave as is. I'm just going to close some of these for space. And so we've updated our clustering code here with this, or these parameters. Again, if you were setting this up on Caesar, you would hit up the reducers endpoint to this aggregation-caesar.zooniverse.org. Pass in the name of the reducer, so in this case, point reducer, HDB scan, and then those keywords get passed as URL parameters. So min cluster size equals 4, and min samples equals 3. So this would end up being the external URL used for your external reducer. One other thing is during this reduction step, if the same volunteer classified the same subject multiple times, there's a flag for changing how repeat classifications are actually handled. So by default, it's only going to keep the first classification they made, since the reason being that's probably the most unbiased since they've never saw the image before. So from a statistical sense, is the one that is going to play nicely with your assumptions on independence of classifications. But if you're doing testing and you've made a bunch of classifications yourself and you just want to see does it cluster, you can just pass in the command -f all to keep all classifications, or depending, sometimes you might want to just keep the last one. So you want to keep their most, so maybe they learned a lot in the meantime and you think that's probably their best answer. You can keep just their last one as well. But it will default to first, and this is same when you set it up on Caesar. There's repeated classifications that's keep first, keep last, or keep all that you can set as well. So let's run this on the command line. So there's going to be 3 different reduce steps, one for each of those extractors. So first, the question extractor. So you pass in Panoptic's aggregation reduce. point it to the extracted CSV file. So that's one subfolder in. Then we pass the configuration file for that reducer. So we pass in the configuration for the question extractor. -O is just the output name. So it's going to put example inside the output name. And -D for what directory to put it in. So here we're going to run the question extractor or question reducer, shortcut reducer, and then this final one is the point reducer. So these are going to come down, and each of them is going to create one more CSV file. And this time, the CSV file is going to have one row per subject on your workflow. Stand page. So here we come over here. We have the question reducer. So now we see for this particular subject, too many to count was said 8 times, whereas yes, I clicked on all of them was said twice, and so on and so forth. So you get a tally for every answer on the question task. So you see what were the raw counts. Similar for the shortcut task. So shortcut reducer. Again, it just does a tally count of how many people said image was too dark or blurry. This particular one is set up so that if this is said, I believe 3 or more times, it gets retired with the retirement reason of blank. So there's a special Caesar rule that looks at the output of this reducer and makes a decision based on what this number is. And then finally, we have our point reducer output. And this, I'm just going to, has a little bit more structure to it because it has a bunch of drawn points. But the columns that are inside of here is you have for each tool, so tools 0, 1, and 2, you have a list of points, X and Y. These are basically a copy of the extracted data. So this is all of the X positions drawn on that image and all of the Y positions for points drawn on that image of a particular tool. Clusters labels. For each of those points, they're assigned to a cluster. So and that is just a label is an integer. So the first cluster it finds gets label 0. The second one found gets label 1. And any point that's marked as an outlier, so not belonging to a cluster, is actually given a label of -1. So you can also identify the outliers here. Then HDB scan also, because it's looking at the lifetime of these clusters, it actually gives the probability of each point belonging in a cluster. So this is a number between 0 and 1, which says how likely does this point belong to the cluster label that it was given. So again, there's 1 point for, or 1 value for each point in the list. And then cluster persistence for each unique cluster label, how long did that cluster live? So a 1 means it's a stable cluster, so it had a long lifetime. 0 being an unstable cluster, meaning it had a fairly short lifetime. It's sort of like the probability that that cluster actually exists, which is going to be useful for plotting here in the next notebook. Cluster count. So for each identified cluster, how many points are inside of it? So how many volunteers identified each penguin? Clusters X and Y are the center of each cluster found. So again, for each unique cluster, where is it centered? And then the variance and covariance of that cluster. And so variance in the X and the Y and the XY covariance. And these final 3 columns are what we're going to be used to be drawing basically uncertainty ellipses around each penguin in our next notebook. So if you want to play around with this a bit on your own, the main knobs that you can tool in this or turn in this clustering are this min cluster size and this min sample, which I can go into more depth if anyone's interested in exactly what those do. But I can also point you to the HDB scans documentation under parameter selection. Does a very good job of explaining what each of these parameters do with nice example images. So now that we've reduced this data and we have this large CSV file with a bunch of columns, let's plot this up and see what it looks like and see how well our clustering actually worked. So to do that, we're going to be closing a lot of these tabs and then coming over to our plotting functions notebook. I'm going to go through this fairly quickly because a lot of this is just a boilerplate for making a plot rather than anything scientifically interesting. So we're going to be importing a lot of plotting functions. So matplotlib for the main plotting. Panopti's aggregation has a nice CSV utilities that we're going to be using to help read in the data into a more useful format. We're doing a bit of linear algebra, so we have to pull in some SciPy, NumPy, and Seaborn for doing some colors within the plot. We're going to be drawing 2 sigma error or uncertainty ellipses around each penguin. So this is just a function to take that covariance information and that position, construct a covariance matrix, and turn that into a uncertainty ellipse, and then return a matplotlib ellipse object so we can actually plot it. This is a subroutine for taking reading in these images and plotting them at a 1-to-1 pixel ratio, so that each one pixel on the image is actually 1 pixel in the output plot. So that's all this does. And then here's the actual plotting routine. We're going to be making a key, key to the plot, which tells us how many adults, how many chicks, and how many eggs were found. So this is just a dictionary for counting. Here we're calling that function from above to plot the image at the correct size. For each tool, we need to pull out the right column names. This is just string formatting to get the name of the column correct to pull out our values. And then just code for plotting the ellipses, followed by plotting the raw data points. One thing that we're going to be doing is the transparency of the ellipse are going to depend on that probability, so that cluster persistence value. So anything that is a a unstable cluster is going to have a very transparent ellipse, where anything that's a stable cluster is going to be a very opaque ellipse. And the data points themselves, when we draw those, we're actually going to set their saturation value dependent on the probability that they belong to the cluster that they're labeled. So we can see points that were kind of on the edge of being in a cluster and have those pull out as a slightly different color. So that's just a subroutine. And now we're just actually going to call those. So we need to point this to where our reducer file is. So our the reduction CSV lives in this subfolder. Read it in with pandas, and then call this unJSON data frame. The reason for this is the data columns that are lists will actually be read in as a string through pandas. All this does is evaluate the string back to a Python list so that you can then use it as a list object. And the images themselves, this is just a formatted string to point to where the images are in the subfolder of Penguin Watch subjects. And these are named off of their subject IDs. So we're just going to create these, read in the data, pull out the first row of the reduction, call our plotting function on the subject ID, and show it here in the browser. And we can see how the clustering actually went. And we did a pretty good job. So the adults are marked in red. It found 28 adults, 3 chicks here marked in green. So it did a pretty good job up front. But there's a little something weird happening back here. And you'll see here we have some fairly faint ellipses. So these are highly transparent, where it's clustered a bunch of penguins together. So even though it found this as one penguin, it also put the transparency pretty low, which tells us this is a low probability of being a real cluster. So we have some information that we can use to automatically say, we probably can't trust the data back here. And then if you want to run this across all of the images within the data, you can then throw this routine into a for loop, loop over all of the rows in the data table, and this will output everything in this aggregation results PW cluster file. So I'll just set this running, and we can see as it goes, it'll start populating and saving a bunch of images to disk. Here we go. So now we can open these up and see how it did across many different penguin images. So yeah, there's a bunch of interesting things that you can do. So this showed the workflow for what if I wanted to use exactly the same clustering parameters for every type of point being marked. But what happened on the Penguin Watch project is they found that for the adults and the chicks, they needed different aggregation parameters for it to actually come out well. So what they ended up doing is at this configuration step, they made one configuration that just kept tool 0 and a separate configuration that kept tool 1. So made two different extraction files, one for the adults and another for the chicks, and made a different reducer config for each of those with their own parameters as needed. So even though I'm passing them all in at once here, you can split them up and do a little bit more advanced setups like that. So yeah, this is showing how this all ties in the offline mode. But everything that is within the Panoptes aggregation code base is available on a server that's running here at this aggregation-caesar.zooniverse.org as API endpoints in the extractors and the reducers that can be set up for using everything within Caesar. So Caesar essentially takes everything that we were just doing with CSV files, but does it with a database system online. So every time a new classification comes in, it gets passed through the extractor, and that passes back here into Caesar, which stores it in a database, which then passes those on to the correct reducers. And then after the reductions are done, you can set up rules that look at various columns within that reduction file. And depending on if those rules are met, those can then trigger effects. And those effects could be retire the image. So for Penguin Watch, I can actually show exactly their setup here. So that might be a little bit interesting. So Penguin Watch time-lapse cameras. So here you can look at their extractors. So they have a specific extractor called a blank extractor. So this is that shortcut task. So even though we've set this up to use an external reducer for point data, there are internal reducers within internal extractors and reducers within Caesar that do things like do that shortcut task for finding blanks, a pluck field extractor for grabbing metadata out of an image, question and a built-in question extractor, which works identical to the one in the offline through the aggregation code, one for survey tasks, and so on. So they set up a blank extractor for task key T0. So that was, is it blank? They have a stats reducer to count up how many blanks there were. And they have a rule saying if the blank count is greater than 3, trigger the effect, retire the subject, and retire it with the retirement reason blank. And that's kind of how it would look in this Caesar setup. Okay, I think that's all I had prepared. So if there's any questions, I know I went through this a little bit quickly, but I wanted to do a slightly more involved example so you understood how all the bits and pieces actually fit together. But if there's any questions, yeah, you can ask.
Thank you, Coleman. That was excellent. So very interesting. Does anyone have any questions?
Where did the penguin pictures come from?
Ah, yes, where did the penguin pictures come from? So the Penguin Watch, yeah, no, this is perfectly reasonable. The Penguin Watch project, what they do is they've set up camera traps in Antarctica and neighboring islands. And every season, they partner up with a cruise ship line called Quark Expeditions that does tourist expeditions to Antarctica. And they just tag along and they act as essentially science officers on the ship. So talking to the guests, telling them about penguins and ecology, and in general being an extra staff member on the ship. And the expeditions, they allow them to do this for free because they're getting essentially free labor out of it, with the one caveat that every time they do a landing for the guests, they drop off the Penguin Watch team to one of their camera traps so they can either set up new cameras, change out SD cards, change out batteries, or more recently fly drones over the penguin colonies to get more accurate imagery. Because of the help I was doing with their aggregation, they invited me to go along last year, so I have firsthand experience of where the penguin pictures came from. So yeah, it's quite a journey, but a lot of fun.
Wow. So you've set foot in Antarctica.
I have, yes.
Oh.
So if no one else has a question, I might jump in. So is there, I mean, I assume there is a reasonable upper limit to the sort of amount of computation that an extractor in Panoptes aggregation or a reducer can do?
Yes, that upper limit is, it can be done in a minute and a half. If it can be done in a minute and a half, you're fine. So yeah, I guess that kind of leads into, this is a Python package called, so if you're looking at trying to find it on GitHub, I can actually put a link to this in the general Slack channel. Its name is actually Aggregation for Caesar, because this is aggregation designed to work with Caesar. Very creative with my naming. But it's a standard Python package, and if you're comfortable writing Python and you want to do something a little bit more custom, you can just come in and everything's set up. So here's all the extractors that are available, all of the reducers. So for example, if we want to take a look at what that question extractor, let's do the point extractor by frame. There's a couple of wrappers for setting it up with the drawing tools, so some decorators. But mostly this just comes down, goes in that classification structure, grabs the annotations, grabs the correct task, goes through for each frame. So if you have multiple subjects within your, or multiple images within your subject, it does it for each frame independently. And just pulls out the X and Y values. So find value X and value Y from that, for all of the drawn points. And then it just saves that to a list and it just returns a JSON. So basically you can take this, it takes in this annotation structure and then outputs some JSON. And that JSON is what becomes the columns of the CSV file. So if you want to write something a little more custom, you can just come in and write your own extractor within this. So clone the repository, install it locally, and start writing your own custom code for either the extractions or the reductions. Right now, the most complex reduction tasks that we do are for transcription tasks. For those types of projects, the volunteers are asked to underline text on a page, so one line of text, and then type as a subtask the text of that line. And so for that one, we have to first cluster all of those drawn lines. Then for each of those lines, grab all of the text. And then for each of that text, run natural language processing to give a text alignment table to then line those up to try to come up with a consensus sentence and then return that entire object. At that point, it's not quite returning a flat CSV. It actually is a highly structured CSV at that point. But depending on the complexity of that task, that does sometimes bump up against that minute and a half computation time. And that mostly comes when there's bugs, when it sometimes accidentally thinks all of the lines from all of the volunteers as a single line of text and tries to pass that through text alignment and just gets bogged down. But a lot of these tasks, because you're only really dealing with classifications from maybe 20 volunteers, 10 volunteers, the reducer is only really clustering 10 things or 20 things. So these tend to be quite quick.
Brilliant. Very comprehensive answer. And then I just thought I'd start off by taking the opportunity to show you what happens once the subject and classification exports have finally completed. So this cell finishes, we ran that code that I talked about in my previous talk, and then we can look at the table of subjects that we got back. So this is now quite a long table for all of the subjects that we included in our project up to that point, and you can see that some of them have got this extra metadata that we added with the exclamation mark at the beginning there. Similarly, now, while I was experimenting with the feedback, you'll remember that I actually did 3 classifications, and we can see that we've now got an export of those 3 classifications as well, which is good. Okay, the other thing I wanted to show was, you'll remember at the end of my last talk, I said we would need to set up CSER properly to handle retirement for our non-training subjects. I just thought I'd show you how we would do that. So the first thing that we would need to do is set up another reducer. And the type of reducer that we would set up is what's called a count reducer, and I've already done it here. But if we wanted to do it, we would go over here, create count, click on count reducer. And then all that does is literally count the number of classifications that are going to come in for a specific subject. Okay, then what we do is we create a rule, and we say, and this is our rule here, let me edit it so that you can see the syntax. So what you can see here is that this rule is basically, we're going to look up the count reducer's classifications attribute, default to 0, and see if it's bigger than a constant value of 5, and then return true if it is. And the thing that I still have to do is create an effect for this rule if it evaluates to true. So if we create an effect, we would like it to retire the subject, and the reason would be probably consensus, something like that. And we create that rule, effect, and now we've implemented what would be basically the normal classification count retirement rule that you would set up in the project builder, but through CSER. So that's how we would do that. Right, so now on to the purpose of this particular tutorial, which is to discuss how you would integrate machine learning with Zooniverse. And I think the thing that I really, well, to start with, I want to point out this isn't a talk about machine learning itself per se. It's about the ways that you can use machine learning in combination with citizen science to improve both the accuracy of the results you get, but also the efficiency with which you can generate results. Just for a bit of context, what we're going to do, I'm going to use some examples from a really simple machine learning model that was trained using data from the SuperWasp variable stars project. And here's a picture of it. It's basically the simplest possible convolutional neural network you could think of. And so bizarrely or surprisingly, it doesn't seem to do too badly. So what we ask it to do is we ask it to predict the type of the light curve simply by looking at the image that the volunteer sees, which is why I've called it the auto volunteer. So we're not passing the data to our machine learning, we're just saying, have a look at this section of the image and tell me what type of light curve you think it is. And so this one, it's pretty confident, you might say, that it's an EA-EB type, and I would tend to agree with it. This one, because there's this slight curvature to the light curve here, I suspect it thinks there's a small chance that it could be an EW type, but it's erring on the side of EA-EB. Again, I would agree. This one, it's much less confident about because there's a lot of noise. I'm actually not confident about that one either. This one probably is correct, but folded on the wrong period, similarly, and this might just be noise. But what you can see is we get, and this will come up later, we get a majority, or the most likely class, if you like, looks roughly correct for our CNN, but often it will predict non-negligible fractions for other classes as well. Okay, so let me jump over straight into the tutorial and have a look at this. So again, we're going to be using the Panoptes client package which I've already installed in the previous tutorial, and we'll be using pandas as well as some more standard packages. Okay. And I should have said, if you have a question, please just unmute and shout out, because I can't see any of the chat and I can't see Slack at the moment either. Okay, so we've imported our packages, and so I've written a lot of text here, but the point that I want to make is that if you have a machine learning model, training it can take a lot of time, longer than 1.5 minutes normally. If you want to get it to make a prediction, that's normally fairly fast. So if you had a model, perhaps you could add that to the aggregation for Caesar repository, although another problem is that machine learning models can be pretty heavy in terms of disk space that they take up. So that might be an issue as well. But that doesn't mean that we can't use the results of machine learning models to try and improve the efficiency of our citizen science. And we heard lots of ways that you might want to do that yesterday. So, for example, you might want to, actually, I've enumerated the 2 options. So, for example, what you might want to do is you might want to take all of your data, take a starting machine learning model and ask it to make a prediction for all of your data, and then use that prediction as a metadatum on your subjects, and then ask Caesar to take a look at that metadatum and combine it with volunteer classifications and make a different decision based on the value of that metadatum. So if the machine is very confident that it's this type of object and 1 volunteer agrees with them, you might want to immediately retire. If the machine is not very confident, you might require 3 volunteers to agree with them. If the machine and the volunteer disagree, well, then you might want to get more volunteer classifications. Okay. The second option, and it's a bit more of a complicated option, is that you might want to basically get the volunteer to make the classification, ask Caesar to send that to a service that you're running, okay, and then there's a lot of things clicking at me. There's someone trying to get in. Please ask a question if you want to. So send it to a service that you're running, get that service to make a machine learning prediction on the fly, potentially make a decision itself if it's a complicated decision, or send the machine learning prediction back to Caesar and ask Caesar to make a prediction using one of its rules. Okay, so I made a picture of what I mean by that. Okay, so option 1, you make a bulk machine learning prediction. You create some Zooniverse subjects and you annotate them in metadata with the machine learning prediction. You get some human classifications for those subjects. So these are basically being annotated in a workflow in Zooniverse. You pass those to Caesar, and Caesar has a look at the machine learning prediction and the human classification and decides whether to retire the subject or not, or to do whatever, move it to a different workflow or whatever. Option 2, as you can see, is much more complicated. So where do we start? Let's start with Caesar. So Caesar receives some classifications, let's say, from over here, and it passes them to an external reducer in this case. We'll talk about what an SQS reducer is later in this demo. That sends the results to some external server. So this might be aggregation for Caesar, or it might be a service that you have to run yourself. Then that server is going to ask the machine learning model to make a prediction. Okay, it's also going to take the result of the human classification, put them together, and potentially itself make a decision to retire, although, as we said, it could just pass the machine learning prediction back to Caesar. And then it's going to pass that decision to Caesar, whether it should retire, all the way back to Caesar, and then Caesar will retire the subject for us. Okay, so these are the 2 options that we're going to look at the beginning of this demonstration. All right, so option 1. We get our machine learning model to predict for all of our subjects at the beginning. Now, as I said, this isn't a talk about machine learning. So rather than providing you with a machine learning model that we've trained, what I've done in our GitHub repository here in the integrating machine learning folder, I have provided, come on computer, in the data, I've provided you with some demo sets of images. So if I just look at one of those. So that's what the images look like. And I've also provided you with some predictions, and this will come up later. So there's a table of all the predictions for all of the subjects in these sets of images. Okay, so our data directory is in fact not subjects deep learning. Our data directory is going to be /data, and we should be able to now read in that predictions file. Keep your fingers crossed. Am I in the wrong place?
I think you're missing a slash in your data directory.
That's a good point. Thank you. It's good that someone's on the ball. Phew. Okay, I thought it was in the wrong place, but it's all worked out. So these are the predictions for each of those images, and you can see that there is basically a fraction for each of the different types. So for this one, it's extremely confident that it's a pulsator. Now we can't look at it, so we don't know, but let's find out. Okay, so now we want to create a new subject set. We've done this many times now, and we're going to add a hidden metadatum that we can get Caesar to take a look at. Okay, so let's call it a sensible name. Let's call it ML prediction and keep it hidden. But rather than making that metadatum equal to one of these names, let's just turn it into an integer corresponding to the position of that name in the list of choices. So, well, okay, the list of choices in our workflow. So that was pulsator, EAEB, EW, rotator, unknown, and junk. Okay, let me verify that. Come to our workflow, classify light curves. And so, yeah, pulsator, EAB. Oh, actually, it's the wrong way around, isn't it? Let's jump back. Pulsator, EAB. No, that's okay. It's correct. Right, phew. So anyway, we're going to save that list. And so that's going to allow us to map between names and numbers corresponding to the position. Now what we're going to do, because we want to create a subject set, we're going to log into Panoptes as we have done before using the Panoptes client. So this is boring for you, so I'll try and do it quickly without mistyping everything. Excellent. And log in. And we're logged in. And once again, we need our project ID. And once again, I can't remember it. So let's 14077. And we'll grab our project. Okay. So now we're going to create a new subject set. We'll call it machine learning demo set. And we'll link it to our project and save it. We've seen this before. Okay. Now what we would like to do is get the list of files in one of those data directories. We'll go for the small sample 1. So let's see what that works. So this is the list of files that we're going to basically get our machine learning predictions for, make some metadata to annotate the images and create subjects with these images and upload them to Zooniverse. Okay, so these are the predictions. Let's see what we're doing here. So what I'm doing here is making a list of the predictions. So that will be either 0, 1, 2, 3, or 5 for each of the images. So what I'm doing is I'm taking again this file name, taking the last bit of it, chopping off the last 4 characters and converting what's left into an integer. And then I can use that integer to look up the right row in this table here. Okay, so that's what I'm doing there in that line. Once I've done that, I'm going to append that integer value, the position of the top of the position of the maximum prediction, if you like, the most likely prediction in that row, and also just for clarity's sake, the value of that maximum prediction. So that's what's happening here, and then at the end we'll see it, and we'll see if I got these the right way around or not, which is. No, I got them the wrong way around. So it's the value and then the position, right? Okay, so now that we've done that, we're going to create our new subjects. So I've got my predictions and I've got my images, and I'm going to basically iterate through them in tandem. So I'm going to take from each of those lists, I'm going to take one item, assign them here, and use it to create a subject. This is familiar, but one thing to bear in mind is that for the metadata, I've got a different origin now. This is the Python machine learning demo. My image is there as usual, just for consistency. And as we've already discussed, I'm going to add a hidden metadatum, which is called ML prediction. And my prediction is going to be number 2. So remember again, it's 0 and it's 0, 1, 2. My prediction is going to be one of these numbers that corresponds to the row. Okay, so let me run that. So that's again going to take a little bit of time to upload all the subjects. And then once I've done that, I will be able to add my subjects to a new subject set. So now that we've done that, so we've imagined that we've done that for many, many subjects, right? Doing it for 10 subjects seems a bit silly. Let's say we'd done it for 10,000 subjects. We'd created all of our subject sets. We've uploaded them to Zooniverse. Now we have to set up appropriate retirement rules in Caesar so that it will reflect on the value of the machine learning response and retire if it's one value and not retire if it's another. Okay, so yeah, let's go and immediately do that. Where are we, Caesar? Okay, so let's go back and go to, first of all, our extractors. Okay, so we already have a question extractor here, and that's fine because that's all we really want. We want to look at the answer to the question from task 0. Coleman talked a lot about question extractors in his last tutorial, and we discussed them a little bit yesterday in the introduction to Caesar. Okay, the next thing we want to do is we have this stats reducer, which is going to count up basically the number of annotations that correspond to a particular answer. And it's going to return them as a particular type of data structure that we can use. Okay, and if you remember, we used that here, okay, in one of our rules, which was this rule, and we said if the test stats reducer number 5 is greater than 3, then retire with the subject equals nothing here. So what we would really like to do now is combine this with another rule where we would say if the maximum value of the test stats reducer is greater than 3 and it agrees with our machine learning prediction, then retire, or something like that. So let's have a look at how we would do that. Let's try and modify this rule. I'm glad Coleman's on the call because he can probably help me if I get this wrong. So we have our basic rule here, and now what we would like to do is change this to say and. So we're going to combine two things together with an and, okay? And within that we have our first one, which is saying that if more than 3 people say it's 5, so right, what this is saying, if more than 3 volunteers give the answer 5, which corresponds to junk, then we were going to retire. But now what I would like to say, if more than 3 volunteers, in fact, let's not make it 3, let's make it less stringent. If more than 1 volunteer says that the answer is junk, and now we're going to look up, and what we're going to look up is subject.ml prediction. Did I spell that right? That's the first thing we want to do. Let's just, give that another default. If that equals if that also equals 5, then we'll retire. And I bet I need an extra bracket somewhere, don't I? Yeah, I think I need one more. So what this rule, hopefully, if it compiles properly, will do is now it's saying we would like the 1 volunteer to say that it's junk and the machine to say it's junk, and then we'll retire. So the machine and the volunteer together are combining their decision, which means that we need fewer volunteers to retire as junk. Okay, keep your fingers crossed because this might well fail. Where's the mistake? Mistake is there. Perfect. Right. So what you can see again, what we've done is we've said if volunteer, I've said this before, so I don't really know what I'm saying again, but I will. If one volunteer says it's junk and the machine says it's junk, then we're going to retire. So this is how we've combined an upfront machine learning prediction with a single volunteer's classification to retire as junk without requiring extra volunteer effort. Okay. Can I just ask one person to say that made sense?
Yeah, makes sense to me.
Perfect. Thank you.
Me too.
That'll do. That'll do. Right. So that was option 1. And let me just add my subjects to the subject set now that they've finished uploading. And make sure that that subject set exists. Machine learning demo set. Have a quick look. Have a quick look. Python ML demo. So, okay, it's all looking good. Subjects have uploaded. Okay, so option 2 is that we're going to make the machine learning prediction on the fly. Okay, now there's basically, in order to do that, we need to use some form of external reducer. Okay, so we've heard external reducers mentioned several times already. And if we're going to get our machine learning model to make a prediction, it might be able to do it very, very quickly, and it might be something that we could embed in aggregation for Caesar. I think Coleman should definitely comment on that at the end. However, let's say that it's a much more complicated computation that needs to be done. In that case, what you're going to need to do is send the extract from so you're going to consume an extract from Caesar, and then you're going to create a special type of reducer called an external reducer that will send that extracted data out to an external service which you're running, potentially. You're going to do the computation and then send the result back. And in order to send the result back, you need to put in place another type of reducer in Caesar, which is called a placeholder reducer. A placeholder reducer's only task is to receive data back that you have computed externally. Now, I promised I would tell you a little bit about something called an SQS reducer. The idea of an SQS reducer, and I actually have a picture here, is that it's trying to get rid of the need for project owners to run their own HTTP server. Okay, so SQS, if I can maybe go back, stands for Simple Queue Service, and it's a service that is run by Amazon as part of their Amazon Web Services cloud platform, if you like. And what it is it's basically a queue of messages that lives in the cloud. So if you weren't to use SQS, you would have to do something like this. You would get an extract from Caesar and you would send it to an external reducer. That external reducer would send it to a URL that you'd specified, and there would have to be some sort of HTTP server at that URL listening out for messages that had come from Caesar, okay, all the time. In this way, the thing that has to listen out for messages from Caesar, in quotes, is the SQS queue, which is managed by Amazon Web Services. I should also point out that SQS queues are essentially free. You can log in with a free AWS account, set up an SQS queue, and it is allowed to transmit 1 million messages per month for free. So unless you have a really successful citizen science project, I don't think you'll end up paying for it, at least the way the current billing system works. And then once it's in this queue, you don't need to be running a server anymore. You can just use a standard computer, as I will show in this demonstration, to simply consume messages from that queue and process them externally. and then you send a message back to the placeholder reducer, but you can do that asynchronously. And we've already been sending messages to Panoptes when we create new subject sets and things like that. So pretty much any computer can work in this framework without having to run an HTTP server or something like that. So I'm going to demonstrate how we would use SQS in this demonstration, because I think it's probably the mode that most people will prefer to use. Oops. Ooh, spoiler alert. So the first thing that I want to say is that AWS does provide its own API, but it's a little bit complicated. So what I've done for this demo is I've written a client that makes everything, in quotes again, simpler for you all. And you can find that in the ML demo subfolder up there. It's called SQS client. I'm not going to open it because it looks a little bit frightening. But the important point is that if I just run that, I've the client. Now, when you set up your AWS account, you will be able to create some security credentials. One of them is called an access key ID, and one of them is called a secret access key. You should keep them secret, which is why I've kept them secret. But earlier on, I put some values here, and so these values do contain not question marks, but basically unguessable strings of characters. Okay, you need to do that before you can use the rest of the client. Okay, what I've also done is set up an SQS queue, and you can do that through the Amazon Web Services interface. It's a little bit beyond the scope of this tutorial, but it's not terribly difficult. And if people want to see how to do this, this is something we can definitely talk about tomorrow. So once you've defined what this URL is of this queue that you've set up, this is living somewhere in the cloud, as you can see, somewhere in the eastern US, then all you have to do is create your SQS client with this simple call here. So it's the constructor of SQS client, and all you do is pass it the URL for the queue. And if I keep my fingers crossed again, so now we've created our client. And depending on whether there may already be some messages in this queue from when I was doing some experimenting, all that we need to do now is consume messages from the queue. So our client has this function, which is get messages, and you have the option to delete them from the queue if you want to, or just leave them there. Now, it's returning three different things here, and this is quite an important thing to remember about SQS queues. It returns messages. Now, messages is a deduplicated version of all the messages it actually receives, because that's what's in this return value. So it's possible, just because of the way that SQS stores messages around the web, that you may get the same message twice when you send a request for messages. However, the SQS client includes functionality to deduplicate the messages for you. So that's what's going to turn up here. And then finally, you get a list of IDs. Okay, and these are the IDs of all the messages that were received before deduplication. As far as you're concerned, that's not very interesting, apart from maybe for debugging. But as far as the client is concerned, it's what it's going to use to delete the messages if I had set this to true. Okay, so let's see if there are any messages in the queue. If not, we'll have to do some work to put them there. And one of the nice things about the way that the messages get returned is that you can just immediately convert them into a pandas data frame to look at them if there are any. So if I just do that, yep, there were a couple of messages there, which is great. So what you can see is that the messages that were in the queue, this is the output of that question extractor. Okay, so what you can see is there is the key, if you like, is the answer. I wonder if I can zoom in on this a bit, actually, because it's probably not that visible to you guys. Yeah, so the key is the answer that was given. So that would be rotator, I think. And then this is the number of volunteers who gave that answer, essentially, or the number of times that answer was given. Now, because we only have single answer questions, this is pretty much always going to be 1. Right, let me Zoom back out again. Perfect. Right. And in fact, I've written that here. So you have the answer and the number of matching responses. So what we would like to do now, these are the human responses that came back. What we would like to do is find those instances where the human and the volunteer disagree. I think that's what I've tried to do. Oh no, where they match in fact. Okay. So what I've done here is I've gone through and I've taken all of our machine, what this code is doing is going through these messages, finding the answer, the popular answer, then looking up the subject using the subject ID, getting the metadata for that subject, doing all of that stuff that we've done before, taking the image from the metadata, chopping off the last 4 characters to get my lookup integer, and then going and looking up the prediction in our table of predictions all the way up there, and then finding out what the predictions answer was and seeing if that matches the human's answer. Okay, and then finally we're going to get a list at the end of basically it's going to contain a Boolean value, did they match, and then it's going to contain the answer from the human and the answer from the machine. Right, so let's do that. Okay, so in the first case we had here's the subject, here's the corresponding image. The human said it was unknown. The answer the machine said was rotator. They do not match. In this case, again, those two are just numbers. Both said it was EW type, and therefore we're going to call it a match. Okay. So we're going to decide now to retire all subjects for which the human and machine predictions match, and this time not just for junk, for any old prediction. So we need to send a message back to Caesar with our decision for the subjects that we want to retire. And at the moment, we haven't set up the reducers properly, so we're going to have to do that before we run this code. Okay. If we don't want to do anything, we don't send the message, and nothing will happen. The project won't retire. Well, the project won't retire the subject. Right. So talked about what we need to set up in terms of reducers. We need to set up, first of all, a new reducer. We're going to create what is called an SQS reducer. Okay, and we will call this, remember, all reducers need a unique name, so that's what this is here, SQS reducer. Unique within the context of your project and workflow. So the queue name, where do we get the queue name from? That's a really good question that I should have covered. If we go back all the way up to the queue URL, the queue name is the last part of the queue URL. You will set that up yourself when you create your queue in AWS. Okay, so this is particular to the queue that I have set up. So I'm going to, actually what I'm going to do is grab the entire URL because we need that later, because that's the thing that goes into this field, the whole URL. Let me remove that trailing dot. And then the queue name, don't worry about the name of the queue. It's got historical reasons. Okay, and there's one other thing that I would quite like to do for this queue, which is that I would like to add a filter, and I would only like to send extracts from a particular extractor. Okay, so I'm going to come back to this in a second. So what this extractor keys lets me do is, rather than sending messages to the queue when every single extractor fires, it will only send messages to my queue if a particular extractor that I'm interested fires. Okay, and for me, in this case, I think it's the question extractor. I'm demonstrating this because we only actually have one extractor on this project, I think. Yeah. So if you had multiple extractors, this would be more useful, but I just want to demonstrate the functionality here. So I'm copying the unique name of this question extractor, and then coming back to my SQS reducer, editing its properties, back down to filters, and here in the list of keys, I just put that there. If there are repeated classifications, only keep the first. This should be familiar from Coleman's talk. And this, remember, if we have training subjects, let me say I'm going to ignore training. I don't want to send messages to the queue that come from training data. Okay, so I'm going to update my SQS reducer. How does it know if it's training data? It has that hidden training subject metadata. Okay, you remember that from the previous demonstration. All right, so that's the SQS reducer. So now we've set up a mechanism to send messages to the queue. We have to still set up that placeholder reducer to receive messages back from the queue. Okay, so let me create a placeholder reducer, which is here, placeholder. And we give that a name, and we're going to say receiver. I can never spell this. Receiver. Excellent. And all of this stuff is just the normal reducer stuff, but it doesn't really make much sense to be applying filters because this is coming back from some external source. We are going to reduce by subject, which is fine. So we create our placeholder reducer. And now that's in place, and we just have to remember this name, receiver. Okay, so now that we've created this placeholder reducer, we're able to send our decisions back from our code back to Caesar. All right, so how do we do that? We're going to use the Panoptes client again. Okay, so we're going to use the Panoptes client. We're going to log in, and we have to specify an additional argument here, which is a redirect URL. And what this is going to do is when we've logged in, it's going to, instead of contacting Panoptes and saying this user is logged in, it's going to contact Caesar and say this user is logged in. Okay, so all this is doing is using the Panoptes client to log into Caesar instead of to log into Panoptes. All right, so let me do that. And I've specified login interactive, so this is just another way of doing it. Instead of me explicitly getting your credentials, you can do it this way, and it will automatically ask me for my credentials. Like that. Okay, right. So now this is the bit of code where we're actually going to send our reduction back. So we have to fill in, first of all, actually there's two things to fill in here. One, this is where the name of our reducer goes, and that's called receiver, if you remember that. And the only other thing that we have to fill in is our workflow. Okay, so let's just grab that from the project builder. Our workflow ID is 17047. And just to talk very briefly about what this is going to do, this is going to send a special type of HTTP request called a put request. It's going to send it to the Caesar URL, caesar.zooniverse.org, and it's going to send it to a specific path appended to that base domain name. And that path is workflows, the workflow number, subject reductions, and receiver. And receiver, again, is the name of our specific receiver placeholder that we set up there. JSON is the payload that we're going to send back. And this does have to have quite a specific format. It has to have, at its outermost level, it has to have one key, and that key should be reduction. And then the value of that key is the data that we want to send with the reduction. And at least one key in that data should be subject ID. Okay, so in ours, the subject ID is one of these, and in fact, it's the second one that we want to send. And then finally, the data that we want to send is, I mean, this is arbitrary. You can make it whatever you want. We're going to send retire true, but it's important to remember what this was, because that's what we're going to use to set up the rule to react to messages of this type. Okay, so first of all, let's hope that this actually does send and not give us an error. Let's try that. Okay, so we got a response back. Let's see, if the response is 505 or something nasty like that, then it didn't work very well. If it's a JSON object, then it did work. Phew, it's a JSON object. So we managed to send it back. We sent our data with this subject ID for this workflow to this placeholder reducer. Okay, so now all we need to do is set up the rule to react to that in Caesar. So let's have a look at how we would do that. So remember, our unique name of our placeholder reducer is called receiver. Let's make a new rule. Just create a rule, and we're going to say this rule is going to be equals, and we're going to look up from our receiver placeholder reducer. And remember, let me just quickly go back here. Where were we? The attribute is going to be this one. It's going to be retire. Okay, so we're going to look up retire from our placeholder reducer. And if it's true, then we're going to retire. And if it's false, then we're not going to retire. Okay. See the dot retire. Okay, and we'll give it a default of false. And this is going to be a constant true. In fact, this is a really good question, and maybe Coleman will be able to answer this at the end. I'm not even sure if we couldn't just look up the value, because that ought to return a Boolean by itself, but I don't know is the truth.
I don't know either. So.
Okay. And it's wrong anyway. Do these have to be a string?
I think you have a period instead of a comma somewhere in the after right there. Yeah.
Yeah. Thank you. Brilliant. Okay. And so now we've set up that rule to respond to our external processing and our placeholder reducer. All right. So a little brief aside, you've noticed that every time I've been trying to connect to Panoptes, I've had to enter my credentials. If you're running some sort of big script or a big program, you don't want to have to do that over and over again. There is a way around that, okay? And what you do is you have to register your application or your program as a client with Panoptes. And to do that, you go to this URL, which is Panoptes Universal OAuth Applications. Click on that. And you register a new application here. Okay, when you do that, it will give you some values, which are your Panoptes client secret, ID and Panoptes client secret. They're very, very similar in structure to the ones that you would get from AWS up here. And you would enter those, and then that would stop you having to constantly input your credentials when you log into Panoptes. However, because they're secret, I'm not going to show you what they are. Okay. So the next thing we want to do is talk about filtering subjects using machine learning. Okay. So the point that I've tried to make here is that machine learning algorithms are really good. In fact, they're superhuman when it comes to performing A, very specific types of tasks, but B, tasks that they've been trained explicitly to do. But there are still some things, as Chris and I think lots of other people, Stephen, have all mentioned, that humans are better at doing. And a really good example of that is spotting things that are unusual, serendipitous discoveries that they weren't really even told to look for in the citizen science project instructions. Okay, most machine learning algorithms, and there is a most in that, won't be able to do that for you. They won't be able to tell you that there's something, that, you know, there's a clown in the picture of a crowd of people or that kind of stuff. Okay, so it would be great if we could show all of our subjects to humans. However, as Chris mentioned yesterday, there are already lots of data sets, and there are more, even bigger ones arriving every single day that are just too massive. They're far too massive to show to humans, even using a platform as powerful as Zooniverse. Okay, so what we can try and do is use machine learning to take those ridiculously large data sets and filter out any of the subjects that aren't really that interesting. So these are subjects that are really, really common in the machine learning algorithms training set, okay? And therefore it can probably classify them very confidently and get them right almost all of the time. And if we can do that automatically, then asking volunteers to do it, it's wasting their time and it's probably not very ethical to do that. So there are some really commonly cited examples of citizen science projects that have used machine learning to try and filter out uninteresting subjects. The most commonly cited one, I think, is probably from ecology projects that use camera traps to take pictures of animals. Now, those camera traps sometimes get triggered by like leaves blowing into the aperture or something like that, and there's no animal in the picture. And it turns out that you can train a machine learning algorithm to predict very accurately whether there's no animal in the picture. And there's no point showing these empty images to humans, or there's certainly no point showing a lot of these empty images to humans. So if we can detect them accurately, we might as well filter them out. And that's been done by a previous colleague of mine who worked in Minnesota. It's also been done more recently for the Galaxy Zoo project, and I think Chris mentioned that in his talk as well. But of course, we're going to use our example from SuperWasp, and we would like to select light curves, which our very simple model is confused. And we're going to make a toy definition of confusing, which is images where the model has predicted two classes with a fraction greater than 0.4. Okay, well, actually more than one, not just two. And I've been away and I've assembled a data set of confused predictions, which I'm going to hopefully read in from my data directory. And as you can see, these are all of the images. There aren't actually that many of them for which the machine predicted more than 0.4 for two objects. Okay, so for this one, it thought it was either junk or unknown. That's not desperately interesting. Do we have any that are more interesting? This one is either a rotator or an EW type, so that would be more interesting. That's just a table. It would be nice if we could have a look at what these images look like and see if we would be almost as confused as the machine. And so for that, I've again made some boilerplate plotting code, as Coleman called it, and added that in the ML demo folder for you. So let's just quickly import that. And then let's plot, how many am I going to plot? Probably the first 6 images from this table and see what they look like. Okay, so this is the one where it couldn't tell the difference between junk and unknown. And are there any experts on the call? Maybe Heidi, what would you call that one? Heidi is not on the call. Oh.
Sorry.
Dropped you in it. I'm really sorry.
2 people in one place at the same time. So which one?
The top left.
Top left. It's a tricky one. I would probably go for unknown.
Okay.
But it could easily be rubbish and junk.
Exactly. So, well.
Oh yeah, it says that, doesn't it?
So yeah, well, there's 2 interesting things though. One is that it is hard, which is good. But 2 is that the machine actually got it wrong. So if we could have got you to label that one, then the machine would have made a slightly better prediction. Okay. Perfect. And similarly for some of these other ones, I mean, I had a look at them. Sometimes it is very difficult to tell the difference between rotator and EW type. Yeah. I think on balance, what would you say, Heidi?
So I would say it's got possibly all of these rotators, the kind of top left and then the next 2. I would say they're EWs.
Brilliant.
But the issue is they're, again, really hard to distinguish, and that at the moment is one of the biggest overlaps we see in this data. The EWs and rotators are confused. So the machine is kind of seeing the same confusion that humans do, which is not unexpected.
It is an auto volunteer. Yep. So there we, and I sampled these literally based on this criterion. So it's not like I'm cherry picking anything here. Okay, so the point being that this would be a useful thing to do potentially to try and retrain our machine learning algorithm using images that it initially predicts two classes reasonably confidently with. Okay, so again, I'm actually not even going to belabor this point. We've seen this so many times now. I'm going to create a new subject set. And actually what I've forgotten to do is add the subjects to that subject set. Oops. Do this again. I see what's happening here. There we go. Okay, so when that's finished uploading, we'll do that. And then that gives me time really just to talk through this last part, which is a little sort of teaser of something called active learning. And so let me jump to here. Yep, you had your is active learning. Active learning, it's a technique where we're going to try and iteratively refine our machine learning model. And the way that we're going to do that is we're going to try and take some aspect of the machine learning model itself or its and decide whether the subject that it's made the prediction for is interesting or confusing or in some sense information rich, in a way that if we were to get a new classification, a new label, and use that label to retrain our model, it would improve our model maximally. It would improve our model as efficiently as possible. And so what you try and do is you try and set up a loop like this. So let's start here. You start with your machine learning prediction and you compute some metric, some sort of selection criterion. So it could be, is it interesting? Is it confusing? If the answer to that question is no, then fair enough, we'll accept the machine learning prediction and we'll retire it. We don't need to show that to volunteers. We think our machine learning model is very accurate and it's done a good job. If the answer is yes, then we're going to create some new Zooniverse subjects, which is what we're doing right now. And we're going to upload them to Zooniverse, get them classified, send them into Caesar, obviously, send them to our SQS or external reducer, and then externally use those classifications, presumably after accumulating more than just one. I mean, I guess you can retrain with just one example at a time, but I think it's probably more effective to retrain with a few examples. Retrain our machine learning, then remake the prediction and select a new set of interesting and confusing subjects with our newly retrained model. And the idea is that by going around this loop several times, eventually you refine our machine learning model until it's really, really good and it doesn't find anything confusing. And finally, we can just process all of our data through, retire it all, and do the science that we want to purely automatically. So that's the idea of active learning. And so this is just a toy example. Where are we? Where's my code? This is just a toy example of how you might set that up. This is taking a long time. Okay, so let's imagine that we've created our new subject set and we go away and we do the classifications and we label them and Heidi has corrected the mistakes that it made. Then they will go into our SQS queue. Okay, I actually really do. Oh, perfect, excellent. They'll go into our SQS queue, and when they come back, because we've added this extra machine learning, original machine learning prediction data, we will be able to use them in some sensible way to retrain our machine learning model. And again, I haven't included the model, so there's no point in me showing you how I would do that here. Let me just grab that. These messages are going to be exactly the same messages we saw before because we haven't done any classifications. And then once we've done that, we would go around the loop again. And so basically, you've now got, in this tutorial, you have almost all of the tools, apart from a highly sophisticated and very clever machine learning model, to try and implement some sort of rudimentary active learning in Zooniverse. And I just want to do one more thing, which is to come and have a look at that subject set that we just created. The confused demo set. Yep, and I just wanted to show that extra metadatum that we added. Object, it can't render properly in JavaScript, so that's unfortunate. Should have stringified it. What I tried to do there was upload a dictionary with all of the different predictions for each of the different classes, so that when somebody was coming along, perhaps an expert, they could try and see where the machine had gone wrong. But you know, we were going so well, we had to have one failure in that demo. And that actually brings me to the end of the demo. So if there are any questions, I'm more than happy to answer them.
I have a question more for my own curiosity than anything. You're discussing the active learning. I mean, as your opinion, I guess, would you retrain the entire network, or would you kind of do more transfer learning type thing and just add in the one more and train it a bit, or 10 more, or however many?
So you mean, would I use the entire data set again?
Yeah, I mean, presumably you have some training data set that you've used to train your network.
Right.
Would you augment this, or?
Yeah, I was just trying to make the distinction with, would I freeze layers in the network, or would I use a smaller data set? I actually don't know. I think that must be a case-by-case basis. If Mike Walmsley is on the call, he's actually got really good. Yeah, Mike, you can probably comment on this much better than me.
I would say, so hi, by the way, I'm Mike. I do active learning for Galaxy Zoo that's running on there at the moment. And if you guys are interested in galaxy morphology, do check it out. We're going to have a data release soon. The active learning is really useful if you really you have a very amount of labeled data at first. As you get more data, if you already have a large set that you can do your transfer learning from, you should start with the model where you've frozen your layers, you're going to do transfer learning. And once you've done your transfer learning, you can then go forward with active learning. So you can really do both. But I would do transfer learning first to get you to a good starting point.
Thanks, Mike. Any other questions?
Hi again, Hugh. Sorry to talk again, but I was wondering, because obviously this is quite new to our C+ Stars project as well, but are there any other projects that have used similar techniques that you know of in Zooniverse that have been really successful, or have any been absolutely disastrous?
I don't know that any have been disastrous.
That's good.
The successful one is Galaxy Zoo that I know about, and Mike's just talked about that. I mean, and also, like I said, a lot of the ecological projects, so Snapshot, Serengeti, for example, but lots of the Snapshot projects, they use this filtering of blanks very effectively. Yeah, you tend not to hear about the disasters, I suppose.
I'd probably add Gravity Spy to that list as well. They are kind of interesting and unique in that they use their machine learning to not only to make predictions and decide what's useful to upload, but to decide how difficult a subject is by saying, well, the ones where the machine learning is really confident, we'll give those to the less experienced volunteers, and the ones that machine learning finds harder or thinks error, and difficult class to the more experienced volunteer.
Yeah,
and Radio Galaxy Zoo is another good one. I think you guys had a talk on that before. But they have a great machine learning pipeline too.
That's true, but at the moment, I'm trying. Well, I would love to convince them to integrate it with the Zooniverse more closely. At the moment, they're somewhat decoupled, so they do all of their machine learning, as far as I understand it, at least beforehand, and then use that to select, not necessarily to select the subjects that are going to go well. Yes, they do use it to select the subjects that are going to go into the project because they need to be large, for example, and extended sources and things like that. More recently, they've been considering ones that are slightly more difficult or complicated, or likely to be retired as blank. And so I mean, this actually goes back to Coleman's talk. So for that project, I wrote a little extension to the aggregation of the Caesar and committed that to the GitHub repository. And so that they're using that to do a particular type of extraction and reduction to try and see at the moment, without retiring, just adding to a collection, how many of the subjects actually just get 3 completely blank classifications from that particular data set that they're considering. And actually is quite an interesting turnout, is that the answer is none. So volunteers are really keen to do at least one thing on a classification. So they have a 3-task workflow, and for all of these subjects, none of them have completely blank for all 3 tasks. So yeah, volunteers are keen to click on something.
I think I'll just add one more thing to what Mike was saying about Gravity Spy. Their machine learning is all done beforehand, so it's not active learning. So it's done when they create the subject sets in the first place. And we are currently in the process of moving their system onto Caesar. So they actually built their project months before Caesar existed. So they're doing it in a completely different way. That's a lot messier. So we're currently working on bringing that into using aggregation for Caesar and putting it onto the Caesar system to do basically their volunteer level up. So trying to do, instead of reducing over the subjects, actually reducing over the volunteers to give each volunteer a score. And when their score reaches a certain point, they get promoted to more difficult workflows. So they have the ability to then go to a more difficult workflow. But we're still trying to figure out how to get that working in the full Caesar system. That's work in progress.
For the moment, Coleman, do you think it would be possible to implement something like, if you really wanted to implement that as an external extractor reducer pair?
That they already exist in the aggregation repo. Gravity Spy. Yes, it's the extractors reducer. So Caesar lets you do extractors and reducers either on subjects or on users. So you actually have that choice when you're setting them up. And so we have a specific user reducer, user extractor, and their subject extractor and subject reducer. But they also have to talk to each other, which is where it gets messy.
Right.
So yeah. Caesar then has to, for each subject, also grab the result of their user reducer to then give the user score to place on, to then give a reduction in the first place. So it's a lot more of a complex setup that we're experimenting with and trying to make sure it's not going to crash everything when we turn it on.
Yeah, it sounds like a very, that's for sure. So.
It's essentially setting up swap via Caesar.
Right. Okay. Yeah, I know what that means. Do we have any other questions? Are there any in the chat? Sorry.
I'll just say that I think this is a really useful, very information-rich tutorial. In fact, a set of tutorials today, and looking forward to it all being online, because I think this is going to be an important resource in the future.
I'm glad if it has been useful information for people. I mean, I'm going to hammer this. I'm really keen that I actually can't see who is on the call, but if people are on the call who aren't currently involved with citizen science projects, or even if you are, but you have an idea for a new one, please come along tomorrow. We would love to try and get some new projects put together tomorrow. And we can try and use any of these techniques, or if you have a simple idea, none of these techniques. The project builder in and of itself will let you build a really nice project.